Finally, welcome to the 3D Modeling and Topology Masterclass, where we're finally going to learn how to 3D model anything. This isn't going to be another course where you're just following me along for 20 hours and copying my clicks. You're going to learn workflows and techniques that professionals use on a daily basis to create 3D models. And more importantly, these are workflows that you can apply to your own 3D projects. We're going to solve problems that early artists and even mid and junior artists encounter on a regular basis. And I'll be talking about exactly how to prevent them, and if you do encounter them, how to solve them. You'll also have access to an amazing community of artists, specifically from my Discord and the course community here. So I'm taking all of my knowledge that I've learned over the past 15 years as an industry professional and as an instructor, and put everything that I've learned into this course. And this course isn't a one and done thing. I'm going to continue to evolve it with your feedback. So as you continue on in the course, be sure to reach out to me with any questions, as well as your other community peers, so we can discuss how to continue to improve this, so you get the most out of it. And those are all part of the initial purchase, specifically for this 3D modeling and topology course. So yeah, I've been there, tutorial after tutorial, hoping the next one is going to give you the skills and confidence that you need. Well, don't worry, because this course is here to give you that confidence to be able to create whatever 3D model you encounter. So with that, let's learn how to 3D model. So I just wanted to spend a few minutes just giving you a little bit more of a background about myself. If you already know this, feel free to move on. But this isn't really going to be a long video, since I'm not really a fan of talking about myself too much. So my name is Anmar Mohammed, and I also go by Anmar's 3D online. Anmar's 3D is just Anmar's 3D spelled phonetically. So it just kind of worked out well that way. And I've been working in industry and teaching for about the same time. I started doing them at the exact same time for about 15 years now. And I'm currently a 3D artist and technical artist at Epic Games, where I'm working on both gaming and non-gaming industries. So I'm a technical account manager, which means I actually work with these different types of industries on the best ways and best practices on how to use Unreal Engine. So that includes automotive, manufacturing, simulation, as well as gaming and media and entertainment. So I get to touch a lot of different industries and get insight on how all these different companies are using Unreal Engine. In addition to that, I've done some game modeling and modeling for VFX. So I've worked with EA, and really early on in my career, I don't have an IMDb page because I kind of was subcontracted to work on models for movies, but I did get to work on a few models for Transformers way back when, which is no surprise being kind of automotive and hard surface. I've also partnered with companies like Autodesk, Chaos, and previous to Epic Games, I've worked heavily with Ford, GM, and other automotive companies. I basically have touched almost every major automotive company in the industry, and then also non-automotive, so fashion, apparel, lifestyle, and even some aerospace stuff. So you can take a closer look on my portfolio that I have on my ArtStation, which really only features work from about 5 years ago, since I kind of rebuilt it for ArtStation when everything kind of switched back then from CG Hub to ArtStation. So again, you'll see heavily automotive for my professional work, and then you'll also see a lot of my tutorial stuff, and you'll see aerospace and a lot of various things, including some shoes. One interesting one that I really enjoyed was like way back when is like creating the digital or virtual library for all of the classic Vans shoes. So that was pretty cool. And they use that for interior design, marketing, advertising, and all sorts of things. And of course, if you're here, you probably know about my YouTube channel. My YouTube channel consists of basically everything 3D modeling and 3D art. So going through that, you'll see that you can learn about 3D modeling, UV mapping, and this led me to create this course since I just kept getting a lot of requests and questions about really the best way to approach 3D modeling. So that's what this course is about. So I'm hoping everybody benefits from it as much as they can. In addition to that, as an instructor, I've been teaching and I've been helping students get in industry via either if it's for games, movies, VFX, product visualization, marketing and advertising. So with that, I think you have a good idea about my credentialed background and that you're in good hands as we continue to move on for this course. So with that, I'll see you in the next one. Let's talk about how to approach this course. Remember, this course isn't about following clicks. It's about learning workflows that'll equip you on how to 3D model anything. So you want to make sure that you're approaching this not like any maybe previous courses. You're not going to have to watch 10 to 20 hours of me just doing clicks and then you copying those clicks. So for example, even for this specific video, if you click on how to approach this course, I have a breakdown of what you should be expecting and how you should be approaching it. So for every module, you'll have this breakdown of what to expect for that upcoming video. So do make sure not only just to click on the video and start watching, but take a few minutes to read what the goal is and the objective for this module is. Here you can see that each video is going to include both concept and theory, as well as practical examples. So it's not just here's a specific way to solve this very specific problem. It's going to be, here's a general approach to this workflow, and here are different ways you can apply it to challenges that you encounter during the 3D modeling process. I not only explain how things should be done, so the do's, but also the don'ts, right? And how you encounter those issues. Over the years, I've seen students encounter the very same pitfalls. So that's where I have that section of do's and don'ts and how to fix them and how to really avoid them and even putting yourself in those positions to begin with. Then as we wrap up each module, there'll be a specific modeling exercise. So the goal for that is for you to kind of follow along and see how I'm approaching that specific exercise. Again, it's not meant to be follow click by click. Now, the first two modules will be real-time explanation of how I do things. For example, if I head over here, you can see that we have one for Let's Model a Pen. This is a real-time video, and I go through the process of modeling this pen. So you can watch the video and then attempt to model it on your own, or you can use these videos at the beginning to kind of help give you that guidance that you need. Then for the later modules, that's where we really have to start this trial and error and building up our confidence to 3D model anything. So once we get to modeling exercise 3, I've captured the entire process of how I modeled this camera. However, it's not going to be me talking for another 8 to 12 hours. Instead, I have a time lapse which will explain my modeling approach to specific challenges that I've encountered for this model. But I did include the real-time capture. The real-time capture will also include a time code along with the workshop course one, which will also have a time code. So at any given point, you can say, okay, I want to slow this down, or I want to look at this workflow in real time with the knowledge I have from that narration and explanation and concept and theory. So it's just a good way and a good resource for you to understand the workflows that are being applied and see how it's done being in real time. But again, the narration is made so you can follow along at a higher level, but both resources are there for you. This is something that I've been doing over the years where instead of having students just follow my clicks and my exact steps, I explain the workflow that I'm doing, allow them to go through this iterative loop of trial and error and practice until they get it right. So you'll have these larger project and assignments, and then you'll have kind of these sub-assignments in these specific modules. For example, let's jump over here in the course, and if I head over to maybe module 3.3, and I click on circular extrusions, you'll have the Blender file. You'll have an understanding of what is to be expected here. So then I would go into the Blender file and find module 3.3. So if I hide miscellaneous and open up module 3.3, you can see these specific objects here. So if I select them, press period on the numpad key, you can see that we have them here, and then I'll hit Control Alt Z, and then there we go. Now, what I've given you is a couple of example models, and I'll explain the do's and don'ts of how you want to approach these circular extrusions. Then I've also given you kind of a blank slate so you can practice specifically on this object. And this iterative mastery or this iterative practice is for you to come in here, Shift D, X, and just play around until you get a good idea of the concept that's being explained. So you don't feel overwhelmed for trying to keep up and model these concepts. So you will continue through that process for each one of these modules until you get to the modeling exercise. Now, what I do recommend is not to rush through these just for the sake of getting these done, is to stop, watch these videos, make note of all of the notes that I've provided to you, take your own notes, and then practice for about 10 to 20 minutes until it really starts to settle in on the concepts that we're talking about. Some of these are simpler at the beginning, but we are going to hit a lot more challenging concepts and ideas once we get on to the later concepts. So use this time, use these modules, use these exercises to actually learn until the concepts start to settle in. So to truly learn something, you have to, and a lot of people don't like this, you have to assess and test yourself, right? So coming into this example for module 3.3, I want to see where these issues lie. And then now I can maybe apply it to a separate object and say, okay, let me try to add circular extrusions and see where I run into these issues. And you want to do that for each module until it starts to build up into that 3D modeling mastery. Again, this is what I've done in the past for students to learn 3D, is to break down these into specific concepts, have them go through this iterative process of learning, and then applying it to the 3D model that we're creating. Also keep in mind that you don't have to feel the need to model this exact object or this exact camera. I've created it in a way that you can create similar objects, so it doesn't have to be a one-to-one. But again, there's no issue if you want to use these workflows to create that exact camera and scope. Then, of course, as I've brought up in the past, you will have full access to all 3D modeling topology updates in the future. So anytime that I add any new modules, you can see that module 5 has 3. I have about 2 or 3 more submodules that I want to add to this. Those will be part of this course. And even if once I create, which I have planned to create a module 6 and a module 7 and so on and so forth, you will have access to those for as long as I'll be making these updates. But do keep in mind, if I make a completely separate course, like on something like UV mapping, low poly modeling, rendering, so on and so forth, those are all separate courses, but they can be bundled together in the future. So to summarize, the way that you want to approach these is to watch these videos, take notes, implement these concepts on the supplied models and even your own practice models, and then kind of do that a few times until it really sets in. But that practice independently is really a key thing here. So even if this course may be 20 or 30 hours worth of content, you want to add another 40 to 60 hours worth of practice here to make sure that this really, really settles in. It's just what it takes to learn something. And then continued iterative practice and practicing with purpose. Again, that's why I've given you kind of these like mini models to apply these concepts, so you don't feel like you have to model an entirely complex object in order to practice these concepts. And then eventually, once you start building that confidence, you can start modeling your own assets. So not only just modeling the scope and the camera that I have here, but giving you the confidence to model your own objects. You also have the Discord community and the community within the course to ask me questions and request any future updates to the course. So that should give you a good understanding of how to use this course and set you up for success. I'm super excited to go on this journey with you, so let's keep going. So really, before we jump into a lot of the detail modeling and sub-D modeling workflows and techniques, we need to understand the why, okay, the context, right? So sub-D modeling isn't the only type of modeling, and it is not always the answer for everything, right? And this is going to help give you the context of different types of 3D modeling workflows, okay? We have quite a few here being sub-D modeling, and I've included quite a few references for kind of each type of reference as well as just some examples, okay? So we know why we're here today. We know it's going to be for sub-D modeling, and there are some fantastic resources out there that I've learned from myself, and I want to make sure that you also learn from, all right? I'm not here to gatekeep knowledge. And if I'm teaching and explaining concepts and you're still having a hard time learning, reach out to me, but also take a look at those concepts taught by other professionals and experienced instructors, okay? So again, we have sub-D modeling, which is modeling with the intention of subdividing the mesh, okay? This is used in full-on CG animation, Disney, Pixar, DreamWorks. It's used heavily in VFX and also used in things like product visualization, marketing, and advertising, all right? Then we have low poly modeling, all right? Low poly modeling in the sense like low poly, this could also honestly, like if I type in just like game ready, I would say you have different target applications, okay? So the context matters here, whether you're playing like on a mobile device or doing AR, VR versus like having like a very heavy machine like a PC. So you could have a model that could be, 1,000 tries, 500, 1,000, 10,000, or 100,000. Current gen games can be upwards of 200 to 300,000 triangles for a hero asset, okay? And this workflow is not subdividing, and it is using triangles here for optimization, okay? Triangles are completely fine, even on organic objects, as long as you're avoiding them in areas of deformation like here. I'm gonna have a full course on the game ready asset workflow, low poly, baking, all that good stuff. And then we have sculpting, okay? So sculpting, again, is where you just have models that are in the tens of millions of triangle, and all of this is just sculpted, deformed geometry detail here. And you're using things like ZBrush, Blender, Nomad Sculpt, and other various tools, okay? What you'll see here is a difference. You may look at this and say, well, this model looks fine. What this model is here is kind of a remeshed version that is made for sculpting. You can see this has a perfect distribution, a near perfect distribution of quads and faces, which is exactly what you want for sculpting. You essentially need to avoid tries here. This one is the like sub-D version. You can see now we actually have edge flow. Like if you specifically look in this area around this, the bicep going through the shoulder and the pec, this is a nice face loop running here. Versus this, it's just like straight up, straight across, okay? Those are the differences here. And then you have the full-on optimized game-ready asset version here. I included this picture because what I want to explain is like, you can have sub-D models and sculpting that is used in game-ready assets, that's used, as you can see here, to texture bake that detail, okay? So I don't want you to think that just because I'm doing game-ready assets, I'm not using sub-D or I'm not using sculpting. You absolutely are. And it is incredibly crucial to learn that workflow as well. But for now, we're going to focus here. We're going to focus on the sub-D modeling. And for the rest of them, we'll kind of just hit on them real quick. You of course have now CAD, and you have some links and references here. Plasticity has been increasing in popularity. It's a really good tool. I've kind of played around with it a bit. I'm probably going to jump in it more. This is where you're using kind of, I would say, parametric type modeling to output a full-blown triangulated asset. So again, these are for rigid assets. This is not for like characters, but great for props and environment assets. And what's nice is you can create these assets and output them at different level of details. And then we have cloth simulation, things like Marvelous Designer, Clo 3D, Optitex, and these are used heavily in fashion, apparel, VFX, and games. I mean, they're using these heavily. And again, you're taking these heavy cloth simulations and you can bake them down for your game ready assets, or you can just outright use them. They're able actually to output nice quads for that ideal simulation. Photogrammetry is another one that's important. Now this is more of a, you're not really modeling, you're just you're capturing data. So you can here see this example of this crate here, and we have these cameras kind of going around taking pictures. And so photogrammetry, it's taking pictures and then it's outputting this mesh here. And again, this is like creating I would say a VFX ready or a sub-D ready asset. However, you can use these as background elements, rigid body elements, really, really great for props, environment props that are just kind of in the background, or, just props that are there in the scene that don't need to be high level of detail. Because like, if you are like zooming in and doing close-ups, then you need to increase that level of detail, which is where sub-D modeling comes in. Then you have spline modeling. Spline modeling is also, I would call this, you have spline as well as NURBS type modeling, or it's also called kind of A-class or surfacing modeling. This is used definitely more so in enterprise and product visualization, and enterprise being, again, automotive, manufacturing, simulation, where they need to kind of create these nice, simple designs. And you can see it may look initially like quads, but it's not. If you zoom in, you can see that there's these what's called surface patches. So you'll see kind of like, oh, well, look at this giant n-gon here. It's not really an n-gon, it's not polygon. It is NURBS data, okay? That could then be converted to polygon data, which is what you end up with this. But as you're working, you're using a NURBS modeling or spline modeling workflow to kind of help with that initial design and prototyping, because they're not having to worry about manufacturing. Then we have Boolean modeling. I included this one because like it's one of those that has just been growing in popularity over the past few years, and the context is what matters. If you're going in and modeling and just kind of creating concepts, prototypes, completely fine, use this, but use Boolean modeling. I use it myself. I'll even use Boolean models to create that initial prototype, that concept, and then convert that mesh to a sub-D ready asset, which we'll talk about, okay? So, but just know that there are fast workflows for kind of going through, because if you're in that initial design phase and all of a sudden you're sub-D modeling all these early prototypes that are going to be thrown away, you're spending way too much time, okay? So early concept and prototype, fantastic for Boolean modeling, and even like for just rigid static objects too, as long as you clean up the geometry. As long as you're not subdividing those meshes without cleaning it up. Again, you can use Boolean modeling, clean up the mesh for sub-D, then subdivide completely fine. But you won't be able to Boolean and then sub-D. Impossible. And we'll look at examples. Then we have remesh modeling, which is like kind of just taking either, you can use like, if you look at Chamfer Zone, he covers kind of a lot of this. ZBrush covers a lot of this as well, where you're going in and just sculpting, and then you're just remeshing it. You're letting the computer dictate that, and then you can bake that down to something that has cleaner topology. So it's something that works really well and something just worth noting, all right? And to kind of wrap up, just a quick example of the various types of industries and how they may use sub-D modeling. So VFX, of course, like movies, right? Like Blade Runner, really good movie. You can see full on sub-D mesh, subdividing, zooming in. Same thing here. You have a sub-D mesh. As the camera comes closer and closer, you can increase that iterative subdivision detail. Here, same thing. Like you're real close. And imagine you're looking at this on a giant movie screen at whatever super high res resolution. You're going to have to make sure that this subdivides and holds up for that detail. Animation is the same thing. You really want to make sure that you have clean topology, especially for characters, so it's subdivides as it should. Advertising can actually use both. I should say it uses either CAD or sub-D modeling. Like here you can see this example of the Bergen Bank Hollywood by Blend Block Studio. And they have a nice clean sub-D model here for this plane. And you can see it's being subdivided, a smooth preview out inside of Maya. And then this one here, they didn't show the wireframe, but I can assure you I've been working in automotive for years and I see this all the time. Like they're typically going to be using CAD for a lot of that type of modeling. And then the interior is where a lot of that sub-D modeling is happening. Any of those soft parts like seats and shifter boots and all that. Product viz, same thing applies here. Most of the time they're gonna have CAD. Furniture actually is pretty hard to get CAD for because a lot of it is either handmade or it's using soft parts, right? Like leather, cushion, and stuff like that. There really isn't a great software. I mean, actually, like Optitex is like an industry, like enterprise solution for that. But most of the time, it is actually sub-D modeled, as you can see here, to create this nice soft looking detail. And then like, you know, Google's iPhone with Apple and Pixel with Google, like just all of these products here are typically going to be using CAD software. Okay. Now, of course, we'll wrap it up with games in real time. And if I zoom in, like this is God of War, this is behind the scenes. This is actually put out by, they did a talk on this, and I highly encourage you to watch it. You know, I got links for everything here. So links for everything. You can find it, and it's pretty high detailed, and you can see initially at first glance it looks like a sub-D model, but it's not. There's a lot of triangles and high detail areas, especially with anything that's breaking the silhouette like you see here. So this is not being subdivided, but it is very high detail. So you have that end of the spectrum versus like, you know, because Kratos was really high poly. I would say he was upwards of 200,000 to 300,000 tries. This here, with this ARM developer appropriate number of triangles specifically for mobile, now you're getting way down at the other end of the spectrum. You can see LODs, or level of details, getting down to 6,000, 1,500, 750, right? And again, not being subdivided, but you could use a sub-D model to bake down that detail. Okay, and there are, by the way, way more industries. I mean, there's like media and entertainment, which is also VFX. There is simulation, so like aerospace is a big one. So this isn't like the definitive list, and I'll continue to add to this, but this should give you a good idea of all these different types of modeling workflows and how different types of industries are using them. So again, now we're understanding the why and the how. So let's dive deeper in, and finally, let's take a look at what the heck sub-D modeling is in the next module. Before we really start to kick off the 3D modeling, I want to spend a few minutes just getting aligned on what version of Blender we're using, add-ons, and so on and so forth. So as you can see here, we're using Blender 4.1, and that's what I'm using, and that's what I've been using to really develop this course, and I didn't want to upgrade in the middle of that. But just know, if you're using Blender 4.2 or the latest version, you are completely fine, and you will be in a good position to get through this entire course. You really just want to make sure that you are using Blender 4.1, at least that version. So if you head over to blender.org/download, you'll see that you can get Blender 4.2.3 LTS. I ran through and did quite a bit of modeling in here, and pretty much like everything worked as expected, so you're good to go. If you did want to grab the version that I'm using, which again is going to be Blender just 4.1, you can head to previous versions, so blender.org downloads previous versions, and then go to download any Blender, and then they'll have the entire list of kind of all the previous versions, and you can see Blender 4.1 is right over here. With the version now out of the way, I wanted to just spend, again, another few minutes just taking a look at basic UI and basic navigation. Again, I'm really using pretty much like nearly all default here, so it'll make it easy to follow along. So you can basically open any version of Blender and start with this course. So the expectation for this course is you've kind of already gone through the basics of Blender, the UI, you kind of have a good understanding of the hotkeys, but I just wanted to go through and do a quick pass on that. Here in the 3D viewport, if you middle mouse, you can just orbit around your 3D object. Then you can use Shift to pan around and move. And then you can use Control middle mouse to zoom in. So that's middle mouse to orbit around with no other key selected. That's Shift middle mouse to kind of pan, and then Control middle mouse to zoom in here. You can, of course, use the scroll wheel to kind of scroll in. So just get used to using the middle mouse, Shift, and Control to navigate around. Blender's navigation, or I would say transform controls, are a little bit different than industry standard. So if you're using the default Blender, if you left click select your object, you press G, you're going to grab and move that object. If you right click, it'll send it back to its original position. R is to rotate, right click to send it back to its position, and then S for scale or size. Then at the top, you can see that we have layout, modeling, sculpting, UV editing. I'm primarily going to be working kind of in this modeling tab. Now, if you have an object selected and you go to the modeling tab, it'll automatically set you into what's called edit mode. So to manually or enter and exit edit mode, you can hit tab. Now, one thing I'll do is I try to make sure that I normally have screencast keys on. So if I just toggle that on, sometimes it gets a little bit weird if you have it on in one workspace and not the other. And then if you want to pop that screencast open, you can hit N to toggle that on. And then you see you have a kind of a bunch of settings here. Really, the key thing that we're going to be working in is the modifiers over here. So this little blue wrench, so you can go in and add modifiers, and we're going to be messing with a whole bunch of stuff as we go along. And then there's also scene properties where you can go in and make adjustments to things like unit scale and all of that good stuff. And I'll talk a little bit more about the specific tools once we talk about hotkeys and quick favorites. But before I do that, I want to make sure that we're all using the same add-ons. So if I go back to the browser here, and you'll see this in the course or module description, I list out all the specific add-ons that we're using. So make sure to review that if you've missed any. If you go to Edit, Preferences, you can see that we have this add-on section here. Then you can simply type in all the add-ons that I'm listing, like Loop Tools, and then you can just enable that, and that will automatically enable it. Now, one of the main ones that I use is Loop Tools. Loop Tools is a fantastic tool for 3D modeling, and it's a default free add-on in Blender. Continuing down the list, we're going to be using Bool Tool, which is a Boolean tool that helps kind of streamline the Boolean workflow. There's a lot of fantastic hotkeys that speed up that workflow, which you'll see firsthand once we really get into it. Another one is Modifier Tools. Modifier Tools is another one that's really good, where if I happen to go to the modifier, and it doesn't matter, if I just happen to add in a quick modifier, you can see I have these 4 menus here, which just do a good job of kind of toggling, enabling, applying, deleting, toggling, the whole stack, all of that with a click of a button, and really helpful when you have, 3, 4, 5 modifiers kind of sitting in this list. Back to the list here, another one is Auto Mirror. It's just a nice tool inside of Blender. And with that enabled, you actually have to go down to the Edit, and you'll see auto mirror. And this is actually where you'll find kind of all of the specific add-ons that we'll be using, but I'm just calling out the main ones that are being used. So again, if you enable auto mirror, you can see that it's setting automatically a mirror along the x-axis, just like this. So super nice. Now, if I want to go through and continue modeling, you can see that that mirror is set up with the push of a button. Then we have Bolt Factory. Bolt Factory is just a really nice add-on that creates just nuts and bolts. So if I hit Shift A, go to Mesh, and then Bolt, you can see that we have all sorts of bolts, add-ons, and stuff like that. And I go through the process of creating a couple nuts and bolts by hand, and then I'm like, oh, by the way, now that we have that understanding of topology, you can actually take this and modify it to be whatever you need. So again, you can change the head of this, you can change it to whatever you want, fill-ups, flathead, none, and even what type of head there. What's super nice about this is that the geometry is primarily quads, which makes it really easy for us to convert it over to a sub-D ready model. One, of course, I always recommend this, especially for my YouTube channel, is Node Wrangler, but we're not really going to be using this because we're going to be focusing on modeling, but I always just bring it up because it's super handy. And then the last one is the one called Edge Flow by Benjamin Sauter. And if you've never downloaded a custom one, so this is the only one that's not in the add-ons preferences. So if you go to edit, preferences, and then, like I said, like now we want to find Bolt Factory is right there. But if you try to find the set flow tool, it won't show up because you have to download it separately. So just head to the GitHub here, scroll down until you get to installation, and he's got an explanation of exactly how to do it. So really you just want to head over to the releases page, download the zip. Now make sure you download the zip, but do not extract it. Then once you're inside of Blender, you can actually install it manually here. And I just downloaded it and moved it right over here. So you would just simply select it and then install add-on. So again, you would go to edit, preferences, you would manually install it, find that zip and make sure not to extract it, right? We're just grabbing the zip and then you hit install add-on and it's called Edge Flow. So once you search that, you can see that it's enabled here. Great, now that we have a good understanding of the UI, basic navigations and transforms, let's just do a quick pass here on the key tools and modeling tools that we're going to be using over this course here. So I'll select our basic cube here in the middle and just delete these modifiers, or you can simply delete it entirely, Shift A, and let's create a cube. So we have our basic default cube. Now we are in the modeling workspace, and from here, we have again our transform tools, but just know a lot of times I use Shift spacebar and I grab this sub menu here, which actually gives us the gizmos. So you'll see me a lot of times using these gizmos because they're just super handy and a nice way to manipulate things. So it really makes this transition easy instead of like entering tab mode and then selecting like a vertice and then hitting G. Took a little bit to get used to. I'm used to it now, but having that gizmo is super helpful. So I'll right click and kind of send that back. So you press tab to enter edit mode. And then within edit mode, we have vertex mode, edge mode, and face mode. 1, 2, 3, right? So you can see 2, I can select edges, 3, I can select faces. And again, 1, I'm selecting the vertices. Then you have a bunch of modeling tools here that we're going to be using. And if we just run through, one of the big ones that we're going to be using is the inset tool. So if I hit 3 to select face mode, select my face, and then press I for inset to create a new face. And there you go. You can see as I left click drag, it creates a new face as I'm dragging. One thing that took me a little bit getting used to is sometimes if your cursor is right here in the middle and you press I, you kind of get this. It's a little bit stuck because it's based off of this line here. You see it's a little bit tough, this dotted line. So you want to ideally press I from the outside and then drag in. That gives you a little bit more precision. So with that I, left click drag, great. And then we're going to be doing a lot with this inset tool, but with this new face created, then you can hit E for extrude. So now we E, extrude, and then there we go. We've now created a new face by just left clicking and dragging. Again, that's E, and then left click dragging as we need it. Now, there is also a way to extrude along normal. So if I select this face, and let's say I want to select the face loop around it, you can select this face, and then the one right next to it. This is a little bit weird. It's kind of direction oriented if you want to select a face loop. So with that face selected, if you alt click the neighboring face, it'll select the face loop around it, but you have to do it a little bit closer. So you notice like if I'm here in the middle, it's not selecting it. So you kind of need to tell it, I want to select that neighboring face and all the faces around that loop, and then boom, there it goes. Then you can do Alt E, extrude faces now, and you can see what happens. It kind of extrudes it up, like if I again do E, but if you do Alt E and take a look and you do extrude faces along normals, that allows us to select these faces just like so. So we have inset, we have extrude, and then another one that I use quite frequently is the loop cut tool. So I hit Control R, and so now you get this tool where it's looking for me to select this edge loop. So I want to select this edge here, which now will allow me to insert or cut a loop along this edge ring. You can just kind of move your mouse up and down to slide it, or press right mouse button and it'll slap it right in the center. Now I'll Control Z to undo that. So if I hit Control R, but before I select the edge loop I want to add this to, I middle mouse scroll, I can add now more edges that I want. So notice now I can click, drag and slide, right click to slap it right in the middle, and there you go. Then another tool that we're going to be using quite frequently is the knife tool. So here I'm not worried about topology, we're just testing out tools. Is press K for your knife tool and just start kind of cutting in. So left click to cut, left click to cut, left click to cut, and then you're kind of left here. And if you want to keep the cut but stay in knife mode, you can right click to accept the cut but stay in the knife tool. So then again, I can left click here and then drag out and cut this edge, press right click and then press enter. Again, your knife tool is going to be K for your knife tool, and then you can continue to cut as needed. Right click to accept the cut and then press enter. Then you can select your face, triangle, or whatever it is that you want to extrude or modify and press E, and then there you go. It's extruded out now. Now, if we kind of just recap some of these main tools here, so now we can start again by selecting this bottom face back down here. Press I to inset, drag that in, press E to extrude, boom, there you go. And then if I want to add in new edges here to create new geometry, I do Control R, middle mouse scroll, maybe I add 3 edges there, left click like this, and right click, and then now I can manipulate these how I want. And there's a lot of snapping tools and manipulation tools. So with these edges selected, you can of course kind of scale them out, but one that I like to use a lot is the Alt S. So if I grab this edge, let's Alt click this edge now while in edge mode. And if you notice me jumping between vertex, edge, and face mode, you can hit 1 again for vertice, 2 for edge, 3 for face. So 2 for edge, left click, Alt S, move that on the normal. And then now I can select these edges at the end. And this edge, now holding Shift, Alt left click, Alt S, and just kind of scaling these now to create this nice volume. Another tool that you can add to your tool set is using the edge slide. So if I Alt click this edge here, and let's say I want to keep it on this path for this edge here. What I mean is, like, if I, let's say, hold Alt as I snap and get to this orthographic view, you can do GG to slide this edge, which is super nice. And you see how that's sliding. So let's zoom in and kind of see exactly what it's doing, especially in perspective mode. Press period on the numpad and it'll zoom in. So we do G, you see how it moves, and then G. So now it's sliding and you get this little yellow line. And if you want to continue this down that tangent path, you can actually press C, and then now it can continue down that tangent, which is super, super helpful. Then up here, we have other things like transform orientation. So if I wanted to rotate this object, I do rotate and then press Y to only rotate it on the Y axis. And then if I wanted to now move it along this rotational axis, you can see we have global. But if I switch it to local, now I can move it along that axis, that local orientation. There's quite a few more, but that's where you would change that. And then I also have things like transform pivot, which we're going to be looking at later. And then we have snapping. Snapping I use quite a bit, especially with vertex snapping. Once you switch it to vertex mode, you can enable it by using Shift Tab. And so you see how that turns it on. You can also hover over and that'll tell you how. So you can now press G and that will snap by vertex there. You can also do Shift Tab there. And another way is, like, let's say it's off and you only want to use it specifically while you're moving. You can press G and then notice I want to snap it, but I forgot to turn it on. You can actually temporarily enable it by Shift Tab and then boom, it snaps there. And then so a couple of things is looking at the edge flow tool. So if I select this object, press Shift A and press torus. And then let's change the major segments to like 32, maybe 16, I think will be a little bit nicer. And let's rotate this RX. And then hold Control, notice how that snaps. Then press Tab to enter edit mode. And let's say we want to add in some more edges. So Control R, left click, right click. Control R, left click, right click. So kind of get used to just going through before really moving on and getting comfortable with these tools. Now, like I said, a really nice thing to do or nice way to manipulate these objects is by Alt clicking this edge. So let's say I don't have it selected. Alt, left click this edge. Right click, go to set flow and then boom, look at that. So that gives you a really nice way to conform an object to existing curvature. So we just went through a bunch of hotkeys and we're going to continue to use those as we move along. But another thing, or really the last thing I wanted to cover, is quick favorites. If you find yourself constantly going up here and you're like, oh, well, I want to use this tool now. I've modified one axis to the other. I go to tab to enter edit mode, I hit A to select all, and then now I want to use mesh symmetrize. And you find yourself doing that a lot, right? And I want to copy this from positive X to negative X. So I'll switch this from positive to negative, and then you're continuing to do that. And if you're doing that more than 2 to 3 times in a working session, then that means it's either time to add a hotkey for it or quick favorites. So it's super nice and super easy where you can really add anything to either your quick favorites or a hotkey. So again, I can go into here, I can go to mesh, right click anything, and then I can add it to quick favorites. So you'll see like right here, I clearly have quick favorites, and to get your quick favorites, you press Q. Look at that. So quick favorites symmetrize, and there it is. So now I can continue on, work, and let's say I right click and then I set flow, and hey, maybe I say, you know what, I want to add set flow now to quick favorites. So I right click, add quick favorites, and then now instead of going 2 or 3 clicks down, I can just Q, set flow, continue on, A, Q, symmetrize. You see? So it's super fast and super intuitive to do that. So if I left click off, that's how you add anything to a quick favorite, and you can do anything to a hotkey as well. You can do that by going in here or finding anything within the UI. And let's say I like to constantly use the wireframe. So if I go to wireframe, you can see that I set this to shortcut Control Alt Z. So make sure you click on that enable button, and then you can change or add whatever shortcut. So Alt Z is for X-ray. So I like to use Control Alt Z to enable and disable wireframe. So you're going to see me doing that a lot. And then, for example, like you go over here and instead of Z, maybe you do face orientation. I right click that, and I actually have that set to quick favorites under face orientation to make sure I can check the normals. Or you can also add this to assign shortcut, and then instead of doing Control Alt Z, maybe I'll do Control Alt X. So now I do Control Alt X, and you can see how I can add that to a hotkey. For what I'm doing here, I'm using, again, the majority default Blender hotkeys with some slightly modified quick favorites, and those quick favorites allow you to see exactly what I'm selecting. So you're not going to get lost if all of a sudden I'm clicking and doing all sorts of things and you're like, what the heck did he do? He just pressed like 4 commands and I have no idea. I've learned over the years as an instructor, having a custom workflow and custom UI and hotkey setup actually makes it very hard to teach. And I've gotten used to it over the years, so it's no problem. So with that, we should be ready to go. We've either got the same or newer Blender version. We're comfortable with the UI. We know how to transform our objects. We've gone through quite a few modeling and hotkeys, and we understand how to create our own custom hotkeys and quick favorites. And we also have the list of add-ons that we're going to be using. So with that, I'm super excited. Let's move on to the next module. I'll see you there. Let's jump in and find out exactly what is sub-D modeling. So let's start with what happens to each polygon in each face. So in its simplest form, what's happening here is each face is being multiplied by a factor of 4. And I should be explicit in saying each quad face is being multiplied here by a factor of 4. So a single face becomes 4, which then becomes 16, all the way up to 64, so on and so forth. And what's happening is that's every single subdivision. So if I press Shift D X, just to move that in the X, you can see if I press Control 1 to add a subdivision modifier here, you can see exactly what's happening. And each one of these are the level viewport that I continue to add to this model. And as I increase, it will continue to increase the level of subdivision on that mesh. So ideally, these will subdivide nicely, cleanly, and most importantly, predictably as quads. Now, what happens when you don't have quads? When you don't have quads, or you have triangles like here, you see these two triangles here with this quad being split, or you have this n-gon, or, right, so we have this n-gon here, we have these two triangles here, and then we have this pole here. Poles are when you have more than 4 edges coming to a single point. So in this case, I have 5 edges coming to a single point. Then I can subdivide, and this is what happens with one sub-d iteration. Now, of course, what ends up happening is they are still all quads. However, they are less predictable and less uniform, and on curved surfaces cause artifacts. So we have Suzanne the monkey here, which you can create simply by pressing Shift A and going to monkey. Okay, so this is the base mesh here. And with this base mesh here, you can see the differences between this version and the one on the left and the one on the right. Now the one on the left is simply just right-clicking and applying a shade smooth. Now this is smoothing the faces and edges that are connected to each other. And with a smooth all, so if I just do a shade smooth, it shade smooths everything. Now you'll notice that nothing changes here with the silhouette. So if I go to shade flat, everything is the same. And by right-clicking and applying a shade smooth, it's still the same, but what's changing now is the shading. Then we actually have the subdivision applied here, okay? Now to apply a subdivision modifier, you can click the modifier list, type in subdivision, or a quick shortcut default is do like Control 1, 2, or 3, and that'll be adding a subdivision modifier here. Okay, so now we have this subdivision modifier, and if you have this enabled, in edit mode, if I press tab, now you can see we have our cage here, right? So this is our cage, which is the base mesh. So I'm still able, like again, if I grab this ear part here, and then I just press S for scale and just start to move things, you can see what starts to happen. I can start to manipulate the base form with the subdivision updating, okay? Another thing to keep in mind is the level of iterations that you're applying. This is applying at level 1, so just one sub-d iteration. As I continue to add more iterations, so now this is 2 and this is 3, it is increasing again the polygon count by a factor of 4. Now most of the time you're going to be okay around 2 or 3, okay? However, you'll notice sometimes if you get in close, actually, like as an example, if you look at this, if I turn off wireframe unshaded and you look at these both at this camera position with them in full frame, they nearly look identical. There's basically no difference unless I really start pixel peeping here. Then where the extra subdivision comes in is where you get in the camera and really zoom in. Now I can start to see just a little bit. I can start to see the vertices and the edges here appearing on the silhouette. So that's where you won't see that with this third subdivision. So if you find yourself in a position where you need to increase subdivision, this is one of the benefits and the pros to having sub-D models, that you can increase the subdivision at will. Like if you zoomed in all the way on the ear and maybe you're like, oh, well, right there in the ear, we kind of see a little bit of faceting, boom, crank that up one more and you got 4. Now let's look at what's actually happening to the mesh as we subdivide. So I like this example here where I just have this nice simple piece of geometry. Now with this piece of geometry here, again, you can take this and play with it yourself. And if you do Shift D to duplicate and then Y just to move it, you can continue to do things as you're following along with this video. So with this video, or excuse me, with this piece of geometry, I can take this and apply a sub-D modifier. And if this is what I want, then, well, this works great. So I'm going to hit numpad / to isolate these two, then press Alt, middle mouse until I kind of get here in this side view. Take a look at what's happening with the base mesh and the subdivided mesh, okay? One thing that's super important is it's very similar to splines. And you are losing volume. Really, the only areas that it kind of lands on the original vertice is the start end, and this one here as it kind of transitions from this curve to this curve here. So volume loss is very important, okay? Now, if I wanted to manipulate these, just like with the spline modeling, if I go into tab to edit mode and I start to manipulate and I go into 1 for vertice, I can start to move things around. And if I hit Alt X to go, or excuse me, Alt Z to go into wireframe mode, then I can select these edges. And you can see what's happening is that base mesh now, I can move that base mesh vertice and it's impacting that slope in that line. Now, what if we want to maintain that original form? So this is great if you're like, oh, cool, I wanted something organic and I wanted something like this. This will be my new base mesh. Or if you're like, well, I want to hold these corners and hold these forms. And if I want to hold these corners, well, I can press Control R to add in and bring these in closer proximity to the corner. So these are called supporting edges, supporting corners, proximity edges. They're called all sorts of things. But really, you just want to make sure that the closer two edges, two faces, or two vertices are, the closer that they subdivide toward each other. So it allows you to maintain that original form. So the further away this becomes, you can see what's happening to that original form, all right? By the way, you'll notice these pink lines. If I hit N and I just select these border edges like so, you can see that I have a mean crease value of set to 1. That just means it ignores the subdivision, okay? So you can also select those edges and press Shift E and slide or bring those back down. You can see what happens. So if you have your own mesh that you're looking at, that's what I'm doing. I'm just applying creasing so it ignores it for that demo. So with this piece of geometry here, let's go back to this very first one that I had duplicated. And now I want to apply a sub-D modifier and I want to hold its original form. So now we will look at the next one, which I've been talking about, which is supporting edges. So I add in those supporting edges. Great. So everything's looking good there. Maybe I keep this one here because I want it round. But now you'll see that it's losing these forms here at the corners. Well, this is where I'll add supporting edges here on the sides. And then you can see it's doing okay, but if I really want it to do a better job, this is where an even distribution of edges come in. So I'll have Control R, middle mouse scroll to add in more edges here, click and then right click and boom, there you go. You're seeing it now holds that form even better, and then I can move a supporting edge here at the end. So the same thing will apply as I move that all the way down. So now, without creasing, everything is looking and working as expected. And if you still see this faceting here, remember, you right-click and apply a shade smooth, and there you go. Everything's looking as it's intended. So I have this corner that's being held here, and I have this nice smooth transition on this bottom. And then now, you can see actually this corner here is being pulled away from supporting this corner. So that's where an even distribution of edges are going to come in. So I'll add in maybe another edge here at the bottom, not to impact this curve here. And then I'll add in maybe another 2 edges here, and look at how it just brings that corner, that supporting corner, back to support that original form. So you get something like this again. So it's working exactly as it should. So when you take all those concepts, right? So we're understanding what happens when we sub-D, and you take those main concepts, which is going to be primarily quads, holding corners and holding edges, and an even distribution of edges, you get your ideal and perfect sub-D model. And here you can see in this example what happens where everything's kind of coming in. And if I press Shift D to duplicate, right click, and I'll remove the modifier, take a look at how the original silhouette compared to the sub-D version, okay? It's nearly identical, which is exactly what you want, okay? In some instances, you'll have this, you're like, well, I want this to be a smoother transition. That's fine, okay? But in most cases, you want your sub-D to behave very, very similarly to the smooth, or to the smooth shaded. So if I take a look at this smooth shaded one versus the sub-D version, they look very similar in silhouette, and then it's just the sub-D doing the last bit of work. as it's needed. These are references that I have used myself to learn sub-D modeling over the years. The polycount sub-D modeling wiki is a fantastic resources. That's actually where I found the guys Gorilla CG, which is so funny because these guys posted these videos 15 years ago and then just disappeared, right? So they have all these videos. Their sub-D ones are super fantastic and are breakdown sub-D modeling, and very similar to how I did because I learned, because it was 15 years ago, right around when I was starting sub-D modeling. So a fantastic resource. Frank Polygon's also really good. He's got a ton of stuff on Polycount in the forums. He's got great topology examples, kind of what happens. So you definitely want to learn from them, plus a few other websites, including other artists and other professionals like Mudguard Models and Andrew Hodgson, who have really, really good examples in topology breakdowns. And my goal here is to have you guys, to give you access or to at least share this information, because I don't like to gatekeep information. These are a lot of the people that I learned sub-D modeling from, and I want to share that with you in hopes that you continue to learn as well. If you have anybody that you've learned from or really great resources, drop them in the forums, drop them in the Discord, and we'll continue to learn together. Now that we have a good understanding of what sub-D modeling is and the best practices for them, let's see what happens when you don't follow those best practices. So let's look at, in this, our simplest form, a cube. So I have this cube, and the goal here for this cube is to maintain its form as this cube. So you can see what happens in these two examples, okay? So this one is the ideal scenario. So if I hit tab and edit enter mode and disable edit mode here in the sub-D, you can see that we have 1, 2, 3. So I have a 2 segment, so that's 2 faces, or a 3 edge segment here of our corner or our bevel. And then I have an even distribution of edges, and all of it is quads, okay? So this subdivides exactly as it's intended. However, let's say in this example, I just went and did a simple bevel and hoping that the sub-D will do the work. Well, what you end up getting is, because the sub-D model now doesn't have an even distribution of edges, it's taking those corners and pulling those corners away because of the subdivision and the approximation, right? Remember the spline that's happening. So instead of being a nice sharp cube, we get this kind of round, soft looking cube. Then this is an example here of, well, okay, now I have an even distribution of edges, but I don't have those holding corners. And let's see what's happening here. So I kind of just have this simple corner, and it's not using this segment, this triple segment that I have earlier, okay? So I'll show you exactly how to add that in just a second, but in this example though, even though I have an even distribution of edges, I have a simple 1 segment bevel, it's still not quite holding the form that I want if I want this to look like a really nice machined cube. So if I grab this cube here at the end, Shift D, and let's just move it down in the Y, and let's grab this now, and you can use Q and select sharp edges. Now, if you don't see where that is, you can head over to select here and just do select sharp edges. And I use this all the time. So I right click and add it to my quick favorites. So I'll do Q, select sharp edges, and I have all of these sharp edges here. And with these selected, now I know about the bevel weight modifier. We're gonna look at that here, but for now, let's just add in a bevel. So Control B, kind of drag and middle mouse scroll to add in 1 division. Great. So with that, I will just do maybe a 0.1 division with 2 segments. Now 2 segments are 2 face segments. You can see as I increase this to 4, this is what it gives me. So I want this to be 2, and then I will change the shape as you'll see what's happening here. It's kind of rounding this out here for this corner. Well, if I want this to maintain its original shape, I will set this to 1. Perfect, okay? So now if I press Control 2 to add a sub-D modifier, we see what's happening and things are looking okay, but these corners what's happening is the corner edges, right, our holding lines are doing a lot of the work, and they're being pulled away from these corners. So I want them to maintain that form. Now let's add in an even distribution. So Control R to add in. So I'll add in maybe 2 or 3 edges on each side. So I'll do Control R, add in 3, and that works good. And then I'll do the same thing. I'll add in 3 more, boom, there we go. And then notice I'm just doing that all the way about around the mesh. So we have that. So Control R, middle mouse scroll to add increase more, click to add where we want to add it, then right click to throw it right in the middle. Boom, perfect. So now if we look at this with our bevel here, we can see, and right click shade smooth, we can see that these corners are holding the form exactly as they should. And if, right, and so now that these proximity loops are holding it, let's say I was like, well, I want these to be tighter. Well, I can hold alt click, and then press SX to scale in the X axis. And actually, I think these are set to individual origin. So make sure that's set to bounding box center. If it's not, SX, boom. See how I can bring that closer? So I'm scaling in that axis. I'm just separating them, right? So I'll do SZ now. So I can scale these up. And what this is doing is tightening these corners. And this proximity loop is allowing me to do that. So I'll do that with SY, and there you go. Now we have much sharper corners. We have quads, even distribution of edges, and a nice corner. Now if we look at kind of this more organic shape or curvy shapes, this is where these issues are even more important. I would say like they're even more magnified, okay? So we have this nice piece of geometry, and it's subdividing predictably. Now it's nice even quads. However, as you can imagine, I'm sure you've dealt with this before, on curved surfaces, okay? When you have triangles like you see here, or n-gons, right? So the n-gon being more than 4, so n being any number, could be 5, 6, 7, 8, and then tries, okay? Let's see if I press Shift D, X, let's look at that, and if I Control A, apply that, look at what's happening in this topology. Yes, it is still subdividing and maintaining quads. However, this is where that predictability that I was talking about, and this is what is causing so many issues, right? Now, with this, you can see that they're very large faces. Now, a couple things to keep in mind. Well, I have an n-gon and a tri here on this flat surface. Where are the artifacts? They're not there. On flat surfaces, the shading remains intact because we're not deforming, the mesh isn't being deformed. It's not having to subdivide and interpolate between these points on a curved surface. So that is the sub-D kryptonite is using tris and n-gons on curved surfaces, okay? Now, these issues can be reduced, okay? Meaning that if I have this mesh here, you can see that I have a quad, or I have quads, I have tris and n-gons on this. And all this is, if I grab this original mesh, Shift D, Y, move this over, and then just move it GX, just move it forward. I'm just taking that subdivision and applying it like that. Control A to subdivision. So you can play around and kind of add and kind of see what happens. Now for this piece here, we can see that this tri and this n-gon actually is causing a little bit of pinching here. But what happens is because we have a much better distribution of edges, faces, quads, and vertices, that it's being contained in this smaller area, all right? So this helps you manage, mitigate, and minimize the pinching artifacts, which is super, super powerful once you know when and where to do this. A lot of times I'll create the model here, and then once I have the form, I'll subdivide and continue to add in geometry. All right, so very, very helpful and very powerful. And I mean, I would say the best way to go about this, as far as the solution for this, is I would make sure that I'll turn off edit mode. Sorry about that. Turn off edit mode. I will make sure that these vertices or this triangle is not on the curved surface, because I am putting it, right? It is being placed in the worst position possible for sub-D modeling. So I'll select these with this one being my last, hit M, and then do at last. So we're doing merge to the last selected vertice, and I'll do that again. Merge to the last selected vertice, And then let's see if that pinching is there. Nearly gone. I mean, it is barely there. So if you happen to need tries, or and there's an end gone, you were just using that knife tool, which typically happens mostly when you're using a knife tool, and you're cutting in geometry, just move that bad topology on a flat surface. Now I know that's easier said than done, but if you keep that in mind as you're modeling, it will make things way easier. Here's another example of, well, I have all quads, but what's happening here is we're now adding in an intricate detail, and this is again disrupting this corner. So now to fix this type of issue, we need to protect this corner. We need to bring in those proximity loops to protect this detail. I have an entire video on this of kind of protecting your extrusions and protecting your detail. Well, you can see all I'm really doing here, if I turn off in edit mode, is just adding these two edges here to protect this corner, right? This corner is now, I can have it protected by these two edges, which is keeping this geometry away, right? So if I shift D, move this in the X, let's see what's happening here. And I will apply Control A so you can see what's happening as we get a lot of edges and quads here. Even though they're all quads, it's still causing surface artifacts. So to fix that, we do edit or tab for edit, Control R, just kind of bring that closer to this corner, and same thing on the bottom here. Now you might say, well, what if I want to now kind of keep this corner round? You absolutely can. So what I'll do is, like, I'll select that edge here. So I'll go into 2, Alt click this edge and just kind of move it back, move this geometry back a little bit further away, and move this down. And then this is allowing me to protect it, and then I can just kind of now adjust the curvature, okay? Because I have these two pieces of geometry. And so then I want to make sure that this is nice and straight. So I will do an SX0, scale all in the X-axis, so it's a completely nice straight line. So there you go, it starts to hold up a little bit better. And I could just maybe add one more edge in here and do the same thing. So Control R to use your loop cut tool. So XX0, that's good. Maybe move that. So now it's completely gone, right? It's completely gone because now these 3 edges here are being protected from this geometry. And take a look at what's happening if I take this geometry, Shift D, move it in the X, Control A, and look what's happening to that geometry, right? All of that detail, like I just said, this detail is happening on this flat surface. And by adding these proximity loops, it's protecting that detail and allowing me to just modify the form that we need. I have quite a few examples that you can just kind of come in and play around with, and just start with this. Start with this and start to add in those edge loops, start to add in those bevels until you get to an ideal subdivision, right? Here's we have corners with no holding lines. Here we have corners with no even distribution of edges. Here we have even distribution of edges with no bevels. So you have all these different types of models to practice with. I should actually move this over and this over here because it should be, this is kind of the ideal one. So you can see how all of this was done. You have also another example here where if I kind of go in, and you can see how adding in these edges are holding these form and this even distribution. And if I wanted to, Shift D, move this on the Y, it's just a good thing to practice, right? So you're practicing with the purpose and the intention of holding these forms and holding these in areas that you want. Let's say I want to hold this corner here, right? So I can press Control R to add in a loop cut tool and start to click and slide that. So now, okay, I want to hold this corner. I'm going to bring these edges a little bit closer. Maybe I want this to be smoother. That's completely smooth. We're getting a little bit of pinching here. Why is that happening? That is happening because, oh, well, we're lacking that even distribution of edges. So I will continue to go in, add in edges like that, and then add it on the other axes. And now, since I know that these pieces here are my corner edges, I need to make sure that I have another set of edges to hold and protect that corner. And then now when I hit that, boom, look at that. Everything's holding the way that it should be. And then I can make sure to add in one more edge, maybe right here, like that. It looks like I got about everything now. And then, yeah, so we're all good. So you can see how the difference, and I like that I kind of kept it separate from, you know, half and half. So you can see exactly, we're like, okay, if I want to hold the corner, these are what I need to add. If I wanted to keep this round. So a lot of different models to play around with this sole purpose of having you understand essentially the implications of what happens when you do or don't do things. So, and these are low stakes, right? These are just models and topology to play around with. So the goal here, I would say, even before you head to the practice modeling assignment that's next, is just kind of play around here for another half hour, start adding in tries, start adding in n-gon, start adding in holding lines, start moving and manipulating things from the first two module and get a really, really good idea of what is happening. Remember, one of the most important things about sub-D modeling is making sure that things happen predictably. And when you do that, everything becomes easier. All right, so with that, that wraps up this whole module. I'll see you in the practice assignment and future modules. See you there. So here we are in module 3.1. I want to take a few minutes just to understand the differences between sharp edges, creases, and bevel weights, and how I use them specifically within my modeling pipeline. We have, for example, these nuts here, with each one using a different type of, sharp edges, creasing, and bevel weights. So if I select all three, hit tab, you'll see these three distinct colors. Light blue being sharp edges, pink kind of being creases, and then this darker blue being bevel weight. Now, if we look at here, this first nut, and I right click and do a shade smooth, okay, you'll notice nothing changed yet because I already applied this sharpness here. So if I press A to select everything in edit mode under edges, so now right click and then do clear sharp. Okay, this is typically what you will find is right after you're done modeling and you right click and do a shade smooth, it's going to shade everything here based off of the neighboring faces and edges. Now, what you can do now, if I select these two edges or really any edge, and then right click and do mark sharp, you can now see that it is kind of hardened or made this edge sharp, okay? Now it's still having a hard time because it's trying to keep these sharp while smoothing it with the neighboring edges. But what you can do is I have the select and then select sharp edges here, which I have already set to quick favorite. So I'll hit Q and do select sharp edges. Now it's using a sharpness of 30, so it's picking up extra edges in here. You can actually just continue to increase that just a little bit, and you can see it removes those inner edges, which is great. So now with all of these edges selected, I can sharpen these edges with the shade smooth applied. So I can do mark sharp and boom, there you go. Now that sharp or select by sharp angle picked up most edges except for this inner one. So I'll alt click to select this edge loop. Alt click on the bottom. Actually, I think the bottom's going to be fine, but I did a mirror. But anyways, with this selected, right click and now again, mark sharp. And so you can see exactly what's happening. Now, when and why do I use this? You'll notice that there's no subdivision modifier here being applied to this. What I am using is this is just I would consider this the base or the blockout of the mesh prior to any sub-D happening. So I would use this during the blockout phase to make sure everything's looking good. And this will also help me understand if I have maybe any non-flat or coplanar issues. For example, like if I just start to move this, you can start to see that, moving that vertice will help me see shading here of non-flat surfaces. So more specifically, like if I move this kind of around like that, you'll start to see shading artifacts. So that helps me during this phase and helps me kind of troubleshoot the model. But from here, so let's select this mesh now, Shift D to duplicate and just X to move it in X axis. And I'll do Shift D Y. So now I can kind of recreate what I have here. Now, with this selected, I want to apply a crease. So you'll notice if I press Control 2 to apply a sub-D modifier, sharpness does nothing for the sub-D modifier. What it is doing, again, is applying shading and smoothing and hardness or sharpness to the base mesh, but not the sub-D. So what I can do now is I can actually go into edit mode again and press 2 to go into edge mode, and we can do what's called select similar. So what that allows me to select things that have similar attributes here. So the shortcut for that is Shift G, or you can head to the top where you get select similar under select menu here. And you can do by sharpness. So with that, I'll hit Shift G, select by sharpness, and it selects all the edges that have sharpness applied. Then I can open up my N panel. So I'll just hit N to open up the panel, and I can apply a mean crease. So I'll apply a mean crease, boom. Now what this is doing is applying the applying the creasing in our sub-D modifier. And what it's telling the sub-D modifier is for the subdivision to ignore these edges. For example, if I select this, Shift D and X, let's actually apply this now. So I duplicated this mesh and I'll hit Control A. Look at that. Right now with this applied, you can see that these edges completely retain the original form. Now, you can actually use this during your modeling process where you model, you crease, and then now we can go through and bevel or even like subdivide at a much smaller subdivision and apply. And then now I got this base mesh to work with and I can continue to model and do whatever details. I've done that before and I've seen that done and works really well. But you can also, during this phase, with this crease applied and the sub-D, is continue to model without having to worry about putting in holding lines or bevels. This is where it gets extremely powerful. So I just added these 3 edges with Control R, scroll on the mouse wheel to add in about 3 edges here, and I'll do the same here at the bottom. So I'll add 3 edges here, and then I can cut in if I want to preserve this corner. So if I want to cut, so I'll press K for the knife tool, left click here, left click, and then left click, and then press enter. And there you go. Let me turn off edit mode so I can see more clearly what I did. And I've just kind of added these 2 triangles here. Now the reason why is so I can kind of preserve this corner here even without a crease. So I will cut across the same way. So I'm just left clicking, and then right click to accept the cut, and then enter to finish essentially the knife operation. Then I can go back in with my R tool, Control R to insert edge loop, to have my loop cut tool do that. And then there, we're just kind of sliding it. It's not perfect, but you get the idea. I mean, I could actually just slide that back a little bit. And then I go into vertex mode, select these 2 vertices and press J to join these 2 vertices. Great. So all of this is looking good. Select the 2 verts, press J. Now I can say, okay, I've added that in. I'm ready now to use the bevel weight modifier to add the bevels in non-destructively. So I'll Shift D, Y again, and I will do the same thing like I did before, is jump into edit mode and grab one of these edges and do a Shift G, select similar, but this time I want to select by crease. So this time I'm actually going to, again, like I cleared the sharpness, or I didn't clear the sharpness because it's having no impact, you can actually set the mean crease back to 0, set and clear the sharpness, and then set your mean bevel weight to 1. The sharpness really doesn't matter because it's being overridden by the sub-D, but you get the idea. Now if I exit, you can see what happens. Nothing really happens because we have to apply now a bevel modifier. So if you go to add modifier and search, I'm going to type in the word bevel and then move this up here at the top of the list. And we want to set this from limit method angle. We want to set it to weight. So set it to weight. And then we also want to give this 2 segments. So let's kind of see what's happening here. And we really want this to harden up a bit. So I'll add 2 segments. Then I will also reduce the amount quite a bit. Like 0.1 meters is really large. So if I type in like 0.01, there we go. Now we can kind of see how this is holding that form. Don't go too small with your bevels, because if you go like 0.001, the corners become so small that there's not enough pixels to catch any highlights. And nothing is really that thin unless you're doing something with like super tight tolerances in machined metal, which we don't want. We want these highlights, we want these bevels to be picking up highlights. So we can drop that back to 0.01, even like 0.025. Well, that softens it out, but you get the idea. We can definitely maybe 1.5 there. So it catches nice highlights. It looks hard surface. It looks metal. All that's great. Maybe I just set it back to, you get the idea. And all of this is happening non-destructively, so I can continue to make changes as I need. And then you can see this edge here. If I press X, I dissolve that edge. We're now back to all quads, which is great. Now, one thing I want you to keep in mind is, like I brought up in the previous videos about topology and hard surface, is that these corners, right, this beveled corner, those hard corners are being pulled away from preserving that detail of the hard corner. So instead, I've added this edge. That's why I added this edge, this proximity edge, to kind of preserve that sharp corner so it doesn't get pulled away. And you can see it just holds that a little bit better than this side, okay? So that's why I added it. Is it 100% necessary when you're viewing it from this far away? Absolutely not. It's just an example of how you can modify the mesh starting from the beginning modeling process. So again, to recap, we're using sharp edges during the blockout phase. We're using creasing during the modeling phase, where we're starting to add in more edge flow, edge loops, and starting to cut in detail. And then finally, I have this version here, which is adding the modifier of bevel, okay? Using this limit weight method, okay? So it gives you complete control over your model. So this is how I use it specifically. There are a bunch of different ways to use it, but this should give you a good idea of how to understand the differences between sharp edges, creasing, and bevel weight modifier. So with that, I'll see you in the next one. All right, I wanted to spend this module or this video to take a look at how to use a stack of modifiers to create non-destructive modeling. So this is going to allow us to create complexity through simplicity. So if I turn off all of this viewport, you can see this is really the shape that I have for here. So let's take a look at exactly how I got here. So jumping all the way to the beginning, we have this object here. We have this cylinder being cut out or booleaned with another cylinder. So this is the helper object, or the cutter object that we're going to be using, just like this. Now, what's nice is this is active or live, so I can exactly position this where I need it. So I know the exact amount of sides, I know exactly where I want it positioned, and it matches the reference, and it's great. So once I do that, I end up with this piece. So I just duplicated it, applied history, and moved it over here. So if I Shift D, move this in the X, where we have it, great. So I'll move this to in the X. And so from this point, all I'm really doing is cleaning up the geometry and then bringing it over here to bring out that slice that we're applying all those modifiers to. So we'll do exactly that. So if I jump into edit mode with tab, select these two vertices, and we want to merge them at last, which is that last vertice, which means just merge it to the last vertice I selected. And that's what we want. Then I can grab K with my knife tool and just kind of cut this geometry and cut this two vertices and split it. Good. And what that leaves me with, because I'm doing sub-D modeling, it leaves me with all quads. Even though this one's more of a diamond shaped quad, it's still a quad. Then instead of having to do this, right, cleaning all of that up 12 times, right, looking at it and having to do that 12 times, and then doing it on the other side, so on and so forth, we can just use modifiers. So what I'll do is press A to select everything, go to mesh, and then we can do a symmetrize. Now I have this set to my quick favorites, so I can press Q and do symmetrize. And I already have it set to positive X to negative X, and you can see how it copied that and made that symmetrical from both sides of the X axis. Great. So now we'll just kind of move next to the next part of the pipeline. So all that's cleaned up, all of that's symmetried. And then once I get here to the end, I will set this actually back to 0. And I want to slice off and create that slice of the pie. So I know that is going to be this edge here. Okay. Oh, so this is good. I'm glad we caught this before we did anything. But you see that Boolean? It left these unwelded verts. It didn't weld these verts. So no problem. I can go to vert mode with 1, press A to select all, and then M to merge by distance. So I do by distance, use something small like 0.003. So then now if I press tab, go into edge mode with 2, perfect, I can slice that. And this is the slice that I wanted. That's based off a little bit of preparation, so I knew exactly where I wanted this to cut. With these edges selected, I can press V, so it slices and separates it based off that edge selection. Great, and I can press right click to put it back. 3, to go to face mode, and then L. Okay, so now I can essentially just select by linked, or like if you did it the other way around, you can also do Control I and select the invert. Great, so I'll delete these with delete key or X and do faces, delete the faces. Now we're here. So by the way, we want to make sure our pivot was at that center of where the full cylinder was. So the center of the cylinder, because that means that we can rotate based off the X exactly where we need it to be. If you happen to have the pivot moved around, you can use snapping plus the affect origin. Oops, it's right here. Options, affect origins, and then while you're in origins mode, you can move the pivot around exactly where you need it. Okay. So that's how you can snap that back. But for now, everything's working as long as you follow these steps. And then we want to bring in now an empty. So press Shift A, create an empty, plain axis is fine. And we want this in the same exact position, same exact transform as this object that we're rotating. You can see it's 4 on the X axis. So select these, and you have to make sure that it has the same. Otherwise, it's going to apply the transforms, and I'll show you exactly what I mean. So with this selected now, we first want to apply a mirror. So if I type in mirror in the modifier list and then mirror it on the y-axis, we need to make sure we disable it on the x. This always gets me because like sometimes I forget and then it's like, oh shoot, they're overlapping or there's duplicate geo. That's because you have to disable it on the x. So now if I move, we're checking our work, it all looks good, perfect. We're also merging. So this center, as long as it's on the 0, 0, we're good to go. So now we can add an array modifier. With this array modifier applied, we want to apply this as instead of an object, or excuse me, relative offset, we want to do an object offset. And the object that we want to use is this empty right here. So grab your eyedropper, select that empty, boom. And you can see that it moves. Now, if the transforms weren't aligned, you'd start to see this, where it's going to use it based off of that transform and things would start to look a little bit weird. So make sure that the transforms are completely aligned in exactly where they need to be. So with that selected now, we want to rotate this here on the x-axis. Now, I know for sure that with this helper here, I want to rotate this 12 times. So if I go back to the modifier and change the count to 12, but you can see it's a little bit off. Well, I know that it's rotating 360 degrees, so I go 360 degrees divided by 12, boom, it's exactly where I need it to be. Then if I apply a sub D modifier, you can see that things aren't merged, so no problem. In the array, oh, by the way, I probably should explain, I press Control 2 to add a sub D modifier. That's the hotkey to add a 2 division sub D modifier. Anyways, jumping back, we go to merge, and you can see it merged, but it looks a little bit off if I click off. So you need to make sure that under merge, first and last is copies are merged as well. And there it is. So it merges those. So things are looking nice and clean. But now I want to add the last one, which is going to be a bevel weight modifier. So that means I can go in here and let's turn off the viewport visibility so we can see exactly what we need. So you can actually hit Q for quick favorites and do select sharp edges, and it'll select all the sharp edges that you want, which is exactly what we need, just like this. And with that selected, set the mean bevel weight here to 1. And it turns blue. That's exactly what we need. And with this selected, now add in a bevel modifier. So we type in add bevel and then add in 2 segments. And we have to make sure instead of angle, we're using we're using limit method weight. So set that to weight. And then now it's going to make sure that it applies to weight, nothing else, which is based off of this selection here. Then under profile, maybe you want to set this back to the original form. That's completely fine. And then we want to lower this a bit, maybe 0.005, something like that. And then you can change the profile if you actually want. Maybe you don't want it to be as sharp. You can round it out that way. So now let me select the mesh, turn on and off viewport visibility, and we want to make sure to move that bevel above the sub D. And there you go. You have a completely non-destructive, I would say pretty close to procedural type of sets of modifiers, so we can change this however we want. So if I want to change the level of subdivision, increase or decrease that to make these sharper or softer, or if I want to not change the array, but really change anything here in the silhouette or the geometry, I absolutely can, right? So if I, do that kind of, so you can see how all of that is being applied to the mesh, so I can change that. So I want to make sure that we spend a little bit of time as we're going on and doing a lot of this course, that you can get complexity through simplicity and through these levels and series of stacking modifiers to create that level. So it's not all about just manually going in and inserting and cutting edge loops. You can use these, and we're just scratching the surface. There are so many other modifiers that do so many cool things, and we're going to continue to use those as we move along. So with that, I'll see you in the next video. All right, so in this module, we're going to look at how to handle circular extrusion and kind of the best practices when dealing with them. So you can see that we have just kind of an array of circular extrusions. And if I select all of them and disable viewport visibility, let's take a look at what's happening. Now, I've seen this a lot, especially with like early on artists, is that they're like, well, I know I'm going to be subdividing, so I'll just use a square. And then with this turned on, just let the subdivision do the work. Okay, this is very dangerous, all right? And honestly, I can't remember the last time that I've even used this with 4 sides, because even with, you can see 3 subdivisions right now, it's clear that you can still see the faceting here. You're just not getting enough geometry, okay? So I would say, like, there's no reason to ever use 4 sides. Now, 6, I would say, is better than 4, obviously, but I still wouldn't recommend this except for rare circumstances, and if the camera is very, very far away. Like, it's completely okay. You can see, like, if I, again, turn on viewport visibility, bump this up to 2 subdivisions, and I'm pretty far away. Like, this versus this, you can clearly see, like, I have to get pretty far. So this is really camera dependent, but at minimum, I would say you should be striving to have at least 8 sides when you are going through and sub-demodeling, assuming you're using 8 subdivisions, and it holds up very well. You can, of course, go a lot higher, and you can have, like, in this case, I believe this is what, 16, so double. And then with 2 subdivisions, with the viewport viz on, you can see how this turns up. Even with 1, it looks really good. With 2, super clean, even when you zoom in, right? Very hard to notice. Because again, remember, we are subdividing by a factor of 4 for every face. So by starting with this, a square, okay, it does not give us a lot. And you really, really don't want to be in a position, where if I Shift D, move on the X, and then again, Shift D, move on the X here, let's say you're like, all right, well, forget it, I'm running out of time. I'll bump this up to 5. This has now become, nearly 200,000 triangles just for this one piece, okay? Or sorry, 185,000, the total scene right now is that much. This one with 2 subdivisions is only 8. So it's incredibly more optimized. Like again, if I apply, let's see what happens when we apply this. This is pretty crazy, right? This is really, really bad. So not something you want to rely on, because if you're running out of time, you're going to pay for it come render time, because now it has to calculate all of these faces, okay? So again, best practices is if we grab this, Shift D, move on the X, let's do this a couple of times, and we can do this on the Y. So with this one, the good thing is we have loop tools. We have tools that can automatically create this circular shape for us. So as I go in, and let's say I just add in the 8 faces with Control R and Loop Cut tool, and then I press 3 to select the faces, then I to inset, I can right click, Loop Tools, and do circle. And there you go. So this is perfectly circular, and this will work with whatever subdivision of faces. So let's say, I know this is a simple cube shape, but for example, let's say I add in 3 faces here, or 3 edges here, 3 here, and I go back and I select the faces, all the polygons, and press I to inset, and then again, right click, do loop tools, circle, there you go. You get this perfectly nice extrusion or geometry that's ready for extrusion. And there you go. And then I can inset again, and then do an inset, or I would say at this point, I would just do like a merge and then collapse that at the center. Okay. And then of course you can select your edge loops, bevel them as you need, and then everything's looking good. And again, that can also happen here with this 8. And then, of course we have like the bevel weight modifier, but in this case, I'm just showing this as an example where you can kind of select these different edges just like this, and boom, it's good to go. So best practices, definitely avoid 4, use 6 at an absolute minimum, like worst case scenario, if your topology cannot be modified any further, ideally use 8, and you can go up to 16 as long as your topology is good for it. Because the last thing I wanted to bring up is if you are creating a sub-D model and you're trying to texture bake back down to that base mesh or that low poly model, there is no way you're going to get this square to bake into this circle, right? Or that circle to bake onto that square. It's impossible. You're going to have better luck, I would say, if I select this, turn off viewport visibility, better luck with this at 6, and you can still see kind of the issues. But again, if I go back to the 8 here, you can see that that is pretty good and is going to help me a lot better. But that's mostly a texture baking thing. But this should give you a better idea of how we want to handle our circular extrusions. So with that, I'll see you in the next video. On to the next topic, where we're going to take a look at what it means to protect your extrusions. So by enabling wireframe, let's see what's happening. So if I select both of these pieces of geometry, disable viewport visibility, this is really what it comes down to. We have this geometry or this extrusion being extruded from this surface here. However, you'll notice that there is no face loop here. And what happens come subdivision time is that it's using that edge here at the bottom to try to preserve that form. And even with two subdivisions, you can still see it looks pretty rough. I mean, this is two subdivisions, and there are still surface and shading artifacts. Compare that to this, where you have this complete face loop that's preserving this geometry. That is what's important when it comes to this. So if I control click on this face, you can see that it selects that. It converts that edge selection to that face selection. So super important. And if I go into edit mode or show this in edit mode, you can kind of see what I'm talking about. Okay, so you always want to make sure that you have extra geometry to preserve that detail. So if I shift D, duplicate, let's take a look at exactly what I'm talking about. So if I go in, you can see I already have the faces selected, but I will disable this in edit mode, actually, the sub D modifier, and let's go in and extrude. Now, again, we don't want to just do a straight extrusion down. Instead, whenever you're doing this type of detail, you want to inset first and then extrude. Okay, that will give you this geometry, because now it gives you this, again, this face loop to do whatever it is that you need to do. So if I go through and start to add in these edge loops just to kind of hold these forms, these corners here a little bit, we absolutely can. And so that's holding a lot better. And then what I can also do is like select these faces now and do like a nice inset. So you can inset that. So that's protecting that bottom. And then I can now have these edges here, and then I can bevel this. Yeah, I'll just do a quick bevel for demonstration purposes instead of using a bevel modifier. So there we go. You can see that that's being applied. And now this face loop here is protecting this corner from all this geometry. Again, comparing that to here, even if I did a bevel here, okay, so we'll see, because a lot of you may be thinking, well, let me just bevel it and it'll be okay. But take a look at now what's happening. This bevel is now disrupting this original curvature and form. So these edges that were running along here, look at the difference, right? So take a look at what's happening when I undo and redo that, okay? It is disrupting now that curvature, right? And is going to cause even more surface artifacts, which we don't want. And you can see that now this, I'm looking at this face here, okay, is now being pulled away from preserving that corner. But if you compare that with this geometry here, and by the way, this is at two divisions, and we're still getting artifacts. Now I look at this with two divisions, look how tight this corner looks. We are now preserving this corner by having that face loop, okay? So there are so many benefits as to why you want to always do an inset before your extrusion and have this face loop and edge loop that's going to allow you to preserve your details. So, and look how clean that looks, right? So things are looking really good and much cleaner than it would have been over here, because now you can start to even see some of that surface artifacts. All right, so hopefully that gives you a good understanding, and these are all techniques we're going to be following up shortly when we do the modeling exercise. So I'll see you there. So in this module, in this video, I really want to focus on how to use sub-D specifically for modeling form. So what do I mean by that? What I mean is you're modeling in this low cage state, right? And during this low cage state, you are creating this base mesh with the expectation that you will be subdividing it again, right? And that's what's happening here. More specifically, it's so I don't have to go through, like if I took this now, right, and I press Shift D X, and imagine trying to achieve this level of detail here, this nice organic curvature through manual modeling. Can it be done? Yeah, absolutely. Is it going to take you more time? Yes, it will. So I take this here, and now I start to do a bevel, and I'm going up and I change the shape back, I change the shape, let's say back to this shape. You're like, okay, that's looking good. And then I go to this piece of geometry and then I'm like, all right, now I got this curvature here. So now you have more edges to work with, right? Which is, and you're like, oh, okay, let me add in another edge. We want to, on Mars, to keep even distribution of edges. So we go in here and then I start to scale in to help that silhouette because I want to make sure to avoid kind of like these flat edges. So there's a lot to keep in mind, and it's definitely doable. However, you can let the sub-D modifier do the work. Okay, so for example, if I kind of go in here, and you can apply this to any shape, organic shape. And by the way, these are techniques that are used heavily for product visualization, automotive, really anything that has kind of organic and hard surface shapes. So with this selected now, I just have a 16-sided or an 8-sided cylinder. So yeah, so I have, again, a low cage, really low, and I know that I'm going to be extruding this and kind of moving things around, right? So I'm just Control R, add in an edge loop here at the bottom, add one here towards the bottom, and then I'll select this face. So during this phase, right, I will have a sub-D modifier applied, and I'll do it during this cage modeling process. So you're like, okay, cool, I'm going to scale this down. Let's see how that looks. All right, that's looking good. Extrude this up. Maybe I will now extrude and inset that face. We want to hold this bottom, so I'll inset that face at the bottom. And then I'll go through and do a right-click that face and do a poke faces, so it kind of holds that a little bit better. And I'll do that here as well. So I'll select that face, right-click, and do a poke faces. So again, I'm modeling this during this cage mode, okay? And you're like, okay, cool. So we have this geometry here, and now I'll select this top edge here, scale and kind of move that out, scale and kind of move this one out, and things are looking good. Now it's a bit more of a jug, so maybe I add one here in the middle, and again, I'll kind of scale things out a little bit. But maybe I want to just move this up, GZ, kind of scale things out, starting to space things. So we're doing, again, all of this during this preview cage mode. Again, so the expectation is, hey, yeah, I'm going to be subdividing this. So selecting these faces, I'll press Control Plus to kind of grow that selection. So now I can scale this here a little bit, so it's a little bit bigger, and then do a scale Z, so I can just make this a little bit shorter to kind of get that look. And then I'll select the face loop here. So if I Alt Z to go into X-ray mode, maybe I select this here, maybe I add in one more edge. So I like this edge, and then start to scale that a little bit. And again, you're just kind of like you are spline modeling, and it's pretty, low stakes. You're not, committing to anything yet. And there, so you kind of get this really nice shape here that looks organic versus having to do that yourself. Now, you'll see that I'm working in 2 level viewports, but I will not apply it at 2. So I'll do a Shift D, Y, move that over, set this to 1, and then hit apply. And look at that. Now I can work with this. I can completely work with this. And then not only that, is I can completely just continue to model this. So I can delete these faces, and maybe I, select this edge loop here, and GZ, just kind of move things up. We're now adding in new geometry, kind of scaling this out a little bit to kind of create that nice face at the bottom. We'll select these faces here, press M, merge at the center. So you can see how easy that is. And if you wanted to, you could even, you don't have to key, oh, okay, maybe I'll just delete every other edge and then just continue working, right? And so now if you press a Control 1, look at that. You have all that base form there. And not only that, you can see that I added a solidify modifier. So if I go in here now and type in solidify modifier, what did I end up using? Something like, 0.2 meters. So something pretty small, but I want to do that at above the sub D. So if I toggle stack and just show this, maybe 0.2, get it nice and thick. There it is. Maybe 0.1-ish. Beautiful. And you get a nice face. So right click that, shade smooth, and look at that. You get this nice organic looking shape. And you can see I applied that same workflow here. And then of course, like now I can go through and just kind of hold some form a little bit. Maybe I start to add in these holding edges to really hold that bottom corner. So that's what I mean about we haven't committed anything, and you're just using this as part of your modeling workflow. You're not having to worry about once the sub D is applied, I'm done. Okay, you can use this as just part of your modeling process. And I use this again all the time, especially with more organic shapes. So I would recommend go through, try to create a couple of cups, a couple of vases, get comfortable with really manipulating and moving the sub D cage during the modeling process. So hopefully you found that helpful, and I'll see you in the next video. So in this video, we're going to now look at one of the most key and important modeling techniques, which is localizing topology. This is where you finally get to roll up your sleeves and do a lot of manual edge flow and face loop redirection. This is for instances where you want to keep topology local. Okay, so what do I mean by that? You can see a couple of examples here. So let's take this nice clean grid, Shift D, move it in the X. And then with this face here, let's jump into edit mode. Now, let's say you want to add in geometry and you need it specifically on this side. And you go to Control R and you just start adding in a bunch of edge loops, okay? Now this is where it's going to cause a problem, because even right now it's a simple plane. If I had a bunch of other complex topology and edge flow on this other side, the last thing I'd want to do is continue those edges and route them in that direction. So I want to keep it local in this specific area. So there's a few different ways you can do this. So as you can see here, you can create kind of this diamond quad where if I want to add an edge loop, I can go in and just start to cut this edge like so, and it will terminate here. And then now I have this diamond quad. So I'm just using my knife tool like we have been. And then now I can select this edge here and press X and dissolve edges there. Now, if I select that vertex and press GG to edge slide it and move it, there you go. We are still now left with all clean quads that will subdivide properly. And that is keeping now this area or this set of edges to have 4 edges versus this side, which is still maintaining those 2. Another technique that you can use, if I Shift D, move in the X, and just GY, move this in the Y, is you can just kind of use this face loop technique where it's very similar to just kind of selecting these faces and doing an eye, right, for inset, and then just continuing this here with the knife tool. That's all that really is. Because what's nice about this is, and I can delete essentially this edge here, and I can dissolve edges, boom, right? Because we have now these sets of edges that are running here for this face loop, which is exactly what we want. And again, I'm now left with 1, 2, 3, 4 edges, 4 edges specifically here. And what's even great is you can nest these techniques if you really want. So that means that I can go in and let's say I do this kind of initial kind of cutting in. So I'll grab K knife tool and just start to left click cut. And we're just going to continue and create this face loop that is localized only on one side of this geometry. And that's where you really want to practice, right? You just want to have practice and build that confidence to be able to add in that geometry. So let's just, for this example, add one right here in the middle. And I'm cutting in here just like so. And then I'll create that diamond shape quad on the inside. And then if I grab 2, I go into edge mode. After accepting that cut, dissolving the edge, there you go. So now look at how you have all these extra edges, right? 1, 2, 3, 4, 5, 6, 6 edges, right? And you could terminate these to even less here. So I can select these vertices, merge them at the center, and then do an X and dissolve edges. Now this is a, a pretty extreme case, but you get the idea of how you can use this geometry and use these sets of techniques to help localize it and keep it in specifically this area. And this does work great on curved surfaces too. Now you have to keep in mind that when you do use this technique on these curved surfaces, you have to be careful of these poles. So it's not completely free, but you have to make sure you have a good distribution of edges. Okay, so if I Shift D, move it in the X. Now, if I want to create some nice detail in here, again on here, so I'll press Tab to enter edit mode, disable this in edit mode, and then I can just kind of continue to cut up here and create that diamond shaped quad, or that kite quad, like a kite shape. And then I can select that edge, dissolve the edges, and we press GG to kind of move that. And let's see what that looks like with the smooth preview. You can see it holds up pretty well, and it holds up primarily because I have a good distribution of edges here. So now if if we wanted to, we can grab these edges here. If I control click and move, I can Alt S to move that on the normal a little bit. And then now I have this nice surface detail that's kind of coming up and then transitioning away. And that's a really good technique to, again, I use this for hard surface, for car modeling, where I just kind of transition these just a little bit less as it goes into back into that surface that's completely smooth. And again, the last thing I'd want to do is just run edges that run all the way down the length of the model, which we don't want. And here's exactly a couple of two practical examples, right? Like if you're character modeling and you see that you have this mesh here, and if I apply a smooth preview, let's take a look at what happens. So everything's looking pretty solid, pretty good. However, if I wanted to add in more geometry for the fingers, let's say, the last thing I'd want to do is Control R, and look at that. Just a complete mess of edge loop and topology. And this is a prime example of why you do not want to do this. And instead, the way that I would approach this, let's say if I wanted to add in again, I would just start with K, I grab my knife tool, just kind of start with cutting it here. So let's just move it up. It's essentially what I already did here. So I'll just add in this cut around, and then on the underside, I'll do the same thing where I would just kind of cut here to kind of terminate and stop that. So that allows me now to, I should be able to select this face. I need to make sure that I stop that right. Yeah, exactly. That's exactly where I wanted to. So if I now, boom, look at that. And then now, boom, look at that. I now have these two edges being added here, right? That's adding geometry only in areas of my fingers. So I'm using the palm to help kind of stop and terminate and localize that area only to the fingers, which is perfect for what I'm trying to do. And then of course, like I left them open, but you would just select these and press J to join the vertices, right? You're going to have that on the hard surface objects as well, because I want to hold these corners here, but I don't want to just run edges and then all of a sudden now I have these intricate details over here, and I don't want to start disrupting that topology that I have here. So instead, I can use that face loop technique, right? Because like even worse, I have this perfect circle over here, right? This perfect circle. And the last thing I want to do is add in a couple of edges that will run down there just like that. So, and then you can see it just completely messes up that circle and causes all sorts of disasters. And then even now with this, I mean, I can even add in another edge loop. Let's just say if I wanted to just tighten that corner up a little bit, and it has no issue whatsoever anywhere around it. So giving you the complete control, right? And again, how do I add that? Let me just select these edges here on the inside. In this case, it actually works out pretty well that I can select these and do like an inset on these faces. So if I grab all of these faces, you can just do a nice clean inset, and it actually works out pretty perfect right here. However, let's say, for example, I wanted to add in a corner here without doing like something like this. Again, disastrous, causes all sorts of issues. Instead, I would just kind of keep that geometry here, right, as an example. And I would just kind of cut it on the other side too. So, and then I can control, oops, I want to redo that, control R. And then now I can just add in these edge loops, cut in this detail, and you can see I just added it where I needed it, right? So perfectly fine. And of course, like I have a couple of n-gons, which isn't a big deal. Like I can split this now, this face, and I can do that on the other side, but you get the idea. On flat surfaces, this many poles is okay, but again, I'm just showing you as an example. So you know, if I have this now, and then now I've localized this topology here where I can just grab these edges, and now I can say, oh, okay, you know, I want this to be a nice sharp corner, and you go in and boom, I hit tab, we start to get that nice crease corner here through just localizing that topology. All right, so one of the key techniques, and we're now going to take all of the techniques and workflows that we have been in this past module and apply it to the next exercise. So we are going to just put everything into practice and continue to move on, building our techniques and workflows brick by brick and putting it into practical, iterative assignments. I don't like the word assignments, it's just practice for you, okay? So I'll see you there. In this module, we're going to talk about mesh density, and more importantly, for a curved object, but this can still be applied to flat surfaces. So what it comes down to is when you have details in your sub-D modeling, you need to make sure that you have enough edges, quads, and faces in order to support the form and support those intricate details. Because if I take this example of this cylinder here with this circular cutout, and I look at how many edges we have 8 edges, and then we have also this 8 edge cutout here. And you can see it's just giving us all sorts of problems. When sub-D modeling, there is pretty much absolutely no need to start with something that has such a low amount of edges and subdivisions. Let's just isolate and let's just take a closer look because everything's pretty much exaggerated here. We have this geometry here that's curving around for the cylinder while at the same time trying to cut a hole. This is putting a lot of stress here on these edges and these poles. Essentially, they can't hold the form and support this intricate detail, so you get all sorts of artifacts here. And I mean, it is absolutely destroying the surface detail here when it should be nice and flat. So going on to kind of the next sample, we can see that we have this 16-sided segment. So we have about 16 going around, and then we have 16 for this cutout here. We are doubling the amount of segments, and you can see it's already doing a much, much better job. However, we are still getting quite a bit of artifacts here kind of in this area, especially in the same area, right? It's where we have our poles and it's where we have this main supporting edge for the curvature. So it needs a little bit more help. Now, again, context matters and whether or not we're really kind of zooming in, but even from this distance, you know, we can switch different matte caps to glossier ones, and you can see we're running into all sorts of artifacts and distortion here. Moving to the next one, we can see that this one now, we're starting to get into 32 and 64. And really, I mean, spoiler, the more edges that you add, the less amount of distortion you're gonna have, because now this edge here and these poles are now getting the support that they need, and it's becoming, the form is less dependent on this primary edge. So I would say, you know, this 32 edge cylinder here is probably a good start for adding in details like this. And then I go all the way up to 64 here, or no, I'm not 64, this is 48. So 48, so I'm increasing it by a decent factor here, and we can see how much better that's starting to look. And the same thing applies whether you have something circular or something with corners, right? Corners on curved surfaces is again one of those that, like, it's the bane of our existence. So really to fix it, you just need to make sure that you have enough geometry to support that form. So again, this is a good example where we're looking at, a 16-sided cylinder. It's really has no reason to be this low, and it's just causing all sorts of pinching. There's a lot of stress happening specifically on this pole. And now I don't even have an edge here to like really hold this corner a little bit, right? So like I could go in and add in another edge, but then what I have to do is like pull this out so it supports and is a little bit more even. And then we can use set flow, but it does a lot more damage than good. And then here we have a good 32 segments on this one. And then now we have another edge, this kind of proximity edge here, that can be used a little bit more to kind of help control this curvature without completely giving us really noticeable artifacts. Now it starts to pull and break this curvature here. So this is kind of an example of where I say, if I'm going to have hard corners or sharper corners, I'm going to want to make sure that I have enough geometry to kind of support that. Now, one thing I do want to emphasize is if I duplicate and move this, and just for the sake of this demo, let's turn this off with viewport visibility. And if I select all of these faces, I'll hit Control plus, and I just want to really just delete all these faces, okay? Now for these faces now, instead of kind of having this edge be our support and running it down, what you can do is kind of bring this edge, this supporting edge here, and we can split this face. So if I split this face that's kind of running across there, now what that gives me is a little bit of extra geometry to support this corner. So I can split this now where I have this edge running across, and then I have this edge running across this way, okay? So let's see what that's gonna do. What this is doing now is I can actually remove this edge here. Then you can select actually these two edges and dissolve them, and now you're left with this nice supporting edge for this corner, okay? So this works really well, and then this gives you a really nice sharp corner. So then if I extrude and kind of move this in now, so I'll just extrude on the X, SX0 to kind of completely flat that, and then we'll just make this a completely flat surface. I will then just do a simple inset, and then I'm just being quick and dirty here, I will add in this edge to just kind of hold this form. Now we do need to be careful because you can see that it took this edge and made all of these bevels. So I need to select all of those faces with Control plus and set that mean bevel weight back to 0. And then if I bring in this edge to kind of hold that proximity and then turn on our viewport visibility, we can see that on this corner, it helps kind of support this geometry a lot better. And if I wanted to, we have, again, this is a proximity, and you can see it's kind of round here, and on the other side it's even sharper. And then I would say that I would need to add in maybe a few more bevels, because what's happening now is this corner bevel here, or these edges here, are being pulled away from that. So that holds up pretty good. There's still a little bit of pinching. So that's why they are so troublesome on these curved areas that sometimes it's just better to start with a higher proximity, or excuse me, a higher amount of segments. So then you can see exactly this issue on other things. So instead of like a cylinder or curved surface with such a large hole, here is a curved surface with a lot of smaller holes, but the same thing applies. So you can see what we have here. You get all sorts of artifacts and deformation because all we have is this one edge here holding the support form, right? And then that's about 16, so same thing. If we take a look, the distortion and deformation from this pole is being minimized because now we have a lot more edges to kind of help keep this contained in this area. And then we also have this edge here to help support the form. So that's really helpful. And then we're also left with this example here, and same thing, if we look at our poles, and we look at this curved surface, just not enough geometry. And I'm using standard localizing topology techniques to kind of keep this sharper edge here on the surface. And it's again causing so much issues because we have this pole here, we have this pole here, and these edges are being pushed. There's no even distribution of edges. So as you increase the amount of segments on your mesh, we can see it helps actually minimize. So now there is a little bit of artifacting here, but it's not nearly as noticeable. And to be honest, this holds up really, really well with this segment, because now this technique here is being used specifically for each corner here. And it actually, again, looks really good by increasing the amount of segments here. And then we continue to do that as we go along. Like this one is what, about 14 edges. I think this one's here is about 14. So you can kind of see whether or not we want sharp edges, or if you have enough edges here that can actually kind of hold the form without having to add in this detail. So it really comes down to if we want really sharp corners or not on curved surfaces. So to summarize, the mesh density really depends on the level of detail or the amount of intricate details that you're going to be putting on your model. If you know you're going to be having a model with a lot of detail, then do yourself a favor and start with a lot more segments. Don't go crazy. I typically start with about 32, or I go up to 48 or even 64, but you can also use the technique, which we're going to cover next in the next video, which is creating the base form, then subdividing if you want to add in more intricate details. So, okay, with that, I'll see you in the next one. So following up from the last video where we were talking about mesh density, we're now going to talk about a technique where you can model the base form using sub-D-modeling, then subdivide, and then continue on the modeling process. For example, here's an exact issue that I ran into when I was doing the camera modeling. So here's the base form here, right? The base form here is on the left, and you can see that when I did the initial modeling, I did model in the holes for the screws, and then the strap anchors here as well. Now, what you're going to see is the issue that we ran into in the last video where we were talking about mesh density. I am pulling, when I did this initial extrusion, you can see that I'm having to use the edges that are using or supporting the form to do this extrusion. And this is causing all sorts of issues. I kind of knew that I was going to come back and fix this, so it was a quick and dirty way just to punch this hole through and come back and fix it. Now, remember what we talked about with circular extrusions. In this example, I just ended up just using a quad, extruding it as kind of an example of, well, even with two subdivisions, you can still see obvious faceting here. So I put these in kind of as representative, and I knew that I was going to come back. Then when I came back and wanted to fix this, now let's look at the after, right? Because again, in the before, all sorts of surface artifacts were messing up the form of the curvature, and it's just not looking good. No matter what I tried to do this. I do want to add though, you can, there are ways to come in and modify the curvature, right? So for example, we can use, so if I turn off the viewport modifier or viewport viz, and let's say I'm like, okay, I want to add an edge here, add an edge here, and then for these edges, let's use set flow, right? So if I right click, go to set flow, and increase the angle, like in this case, it actually works pretty well where it's kind of going across. And then this one, I can also, so I have just a quick favorites, I can do another set flow. Now, because I have this extra detail in here, I do need to increase the minimum angle just enough where it still gives me the curvature without destroying the geometry. So perfect, that actually works okay. However, let's see what impact this has on the rest of the model. The impact that it has now is that it no longer matches the original base mesh, right? And we have this issue, right? Compared to if you let the subdivision do the work, even with this is subdivided once, based off of this initial topology, look how well and look how perfectly those are lined up. So then I would have to go through and then just manually start fixing this. So I was like, okay, well, now things are a little bit off. I have to go in and start to move these edges, and it just becomes all sorts of a mess. So you don't want to do that in these types of cases. Sometimes you can, but as you can see, it causes more problems than what it's worth. So again, now let's jump back to the actual good version. So all this is just taking this model here. So Control D, and then just move it in the X and subdividing it once. So I would actually remove all of the modifiers, subdivide it once, and then just apply. Of course, I'm always going to make sure that it is fully duplicated at this point. So just in case it's like, oh, well, let me go back and make some edits. It is destructive, but trust me, this will save you a lot of time down the road. So then once you're here, now look at all of this extra geometry. The curvature is completely preserved. And now even my screw holes, like if I turn on viewport visibility, look how good they look, right? They're nice in curvature, even at one subdivision, okay? Because now if I know that this is going to be 2 subdivisions, then let's say I bump this up to 2, then this has already been subdivided. So that means I leave it at 1. But I would say for this camera, for these high-res shots, I'd bump it up to 3 and then this up to 2. And then even at 2 subdivisions, you can see how well that geometry holds up. And because we are using 8 segments on this really small hole, you can't really even notice any faceting or the edges, right? So you have to zoom in super close. And this one, the anchor strap hole, like this is using, because it's a larger hole, it's using 12. And with this 12, even from this distance with 2 subdivisions, holds up incredibly well. Okay, so there are just way more pros than cons as to using this technique where you just model the form. Because a lot of people are like, oh man, how'd you get such clean looking topology and geometry? And I'm like, well, a lot of times I'll just let the sub-D do the work. I know what I'm doing, and I go through and I model the form with the intention of subdividing. And I kind of knew that I was going to have to do this here, but I was like, perfect example. This is an ideal situation that I've run to countless times where it's just like you don't get enough geometry. So we run into this now where we can do the extrusion. So just to kind of wrap up, now I can go in here and let's say I grab these faces just to kind of show how I did it. And I can take these and do an inset with I, okay? And then from here, I can do a loop tool circle, okay? Now I was messing with radius earlier, so set the radius, or disable the radius, I should say. And then we can see this is conforming to the surface, and then I can rotate the angle just until it's about even, just like this, and that looks good. And then I can extrude. That's looking nice. And then I can right click loop tools, flatten if I wanted to flatten this. So you can see how that flattens super nice. And to kind of keep our, actually let me inset. So if I inset this just like that, that's looking good. And then I can inset one more time and do a merge at center, boom, nice and clean. So with this, I'll set the bevel weight to 1 and then apply. So I do have to copy the modifier. So I select this first and this second, Control L, copy modifiers. Boom, yeah. So you want to select the last object as the modifiers you want to copy to the new object. So there, we have those all copied over, so I don't have to manually do that all over again. And there you go. Look how good that looks. Nice and clean, super easy. And then if I happen to want to also do it like, maybe I'll just grab one of these because I don't want to do these for, I mean, I can do, actually I can like do them at the same time. So you do something like this and then right click, circle. And then from here it gets a little bit weird, like I'd have to go in and manually rotate them separately, but again, not a big deal. We grab these faces, extrude in, continuing on, you know, with our inset, and then we can just select these edges with Shift Alt left click just to add to that loop selection. And then here we just add our bevel weight non-destructively. And then there you go. So you can see how beneficial this is. And if I just needed to go back and let's say, oh, let me make, updates to this, I have this base mesh that I can go back to. And I would use this technique on anywhere else that I have intricate details. You can see for the top of the camera, I had plenty subdivisions, even for some of these smaller holes. So that worked out okay. If I had even smaller screws, that's where I would use it. But you get the idea, okay? So this workflow of modeling, subdivide, and then detailing is incredibly, incredibly useful. And I use it all the time, especially when sub-D modeling and anywhere that I'm just working on a high poly object. You can, of course, bake this down to low poly because everyone always says, oh, well, the density is too high. What about low poly? No problem. My low poly is going to be a separate mesh anyways that I'll bake down to a completely different mesh. So with that caveat out of the way, that should be everything that I want to cover. So I'll see you in the next video. Let's talk about how to create panels for your 3D models. This is when you have the full form ready to go, all the edge flow and topology set up, and you want to break it into pieces or panels. This is great for essentially any type of vehicle, any type of mech, any type of hard surface object. I've even used this technique for soft body objects like, vehicle seats and whatnot. So we're going to look at two different workflows, one being a destructive workflow. Like you can see here, there's really only a subdiv modifier, and one where we actually have controls over the bevels, the thickness, and whatnot here. That's a bit more procedural. So let's start with the non-destructive workflow. If I hit Shift D, move this in the X, and let's just jump in here, turn off edit mode in the subdivision modifier, press Control R, and let's add our loop tools. So Control R, or let's add our loops using the loop cut tool. Now, you'll notice that I added this edge here. I want to make sure that it continues the form of that curvature. So if you right click, we're using the set flow add-on, we can see the difference by conforming to that existing curvature. Great. Now we need to separate it into pieces. So you want to select all of the edges, including the one that runs down. You'll notice that in this case, I don't stop it here at the intersection. I continue it on as it goes, and I'll clean it up later. So I'll do a Control B for bevel. And actually, I think it looks like Blender crashed earlier. So it looks like screencast is off. There we go. So we're back in business. So let me undo that, Control B, because I want this to be about 0.01. And if I now extrude, we want to do extrude along normal. So Alt E, extrude faces along normal. There we go. Now remember, turn this off in edit mode. And then we want to now select all of the faces, including the ones that we wanted. Now remember, I actually over selected here. So let me undo that. Control click in face mode. And then now we'll Alt E, extrude along normal. And we'll just do something like -0.05. Great. So then with that, let's just select all the faces on the very edge, delete those, and then here we are. So now, again, like once I've broken up these panels and everything, this is where I can also, put in my holding lines, go through that whole process, maintain these corners. So everything's looking pretty good here. And if I jump out of smooth preview, you can see what happens. I, of course, can hold, add more edges here, but you get the idea. This is essentially the workflow destructively on how to add geometry. And I've used this, and I still use this. And then I guess the last thing is, remember I said we would clean this up. So if you hit X, you just remove those edges and dissolve those edges. Great, so let's look at now how to do that, but kind of maintain our workflow by using modifiers. So if I do Shift D, X, move it in the other direction, let's jump in here and do that again. So again, we're going to Control R, and we're going to add that in the dead center. So Control R, left click, then right click to put it in the dead center. Then we want to add it perpendicular. And again, I have set flow to my quick favorites. Oh no, I didn't, Blender crashed. So we go to set flow, and then you can right click and just add it to your quick favorites. So now when I hit Q, boom, And then from here, we still need to destructively break this into panels. So this is going to happen no matter what. And this is typically what happens when you're doing vehicle modeling, where you, let's say, sub-D model the whole form, and now we need to separate into pieces. So again, we'll just do that at like 0.01, and now we'll delete it. I'm not going to extrude. We're just going to delete it. And I over-selected here, so let's remove those faces, then delete it. Okay, so there we are. Let's also turn off edit mode in the smooth sub-D modifier. And then now, if I press 3, then A, I want to select all my panels at this point, and I want to do a nice inset. Okay, this is going to create a nice edge that is going to be there kind of as a proximity edge and an edge to protect that our corners here. And you can use something like 0.015, maybe 0.025, a little bit bigger, something like that, or 0.02, really doesn't matter. So from here, what we want to do now is continue the process and add in and protect these corners. So if I press K for our knife tool, I want to go to all our corners and essentially just cut these just like so. Now I want you to see something now. If I press tab and look at the smooth preview, what we're noticing here is that it actually subdivides fine with tries. However, if you want to maintain quads, I can press X, and then I can do limited dissolve. Okay, there we go. So I did a limited dissolve. Blender keeps crashing every time I did a limited dissolve, but it seems to be okay now. I did remove the sub-D modifier. My point is, if I exit this, edit mode and press Control 2, add a sub-D, what you'll notice is even with tries here, it will preserve the corner all the same. So it looks completely fine, but you can use a limited dissolve and remove that if you want. Now, let's look at adding now a solidify modifier. So if I go to the modifier tab, and let's add in, you can type in solidify or pick it if you used it recently. Move solidify to the top of the list. And what's nice about solidify is you can see that it has full-blown thickness. However, if we want just that lip or that rim of faces, you can change this to only rim. And so now it won't even worry about doing the back sides. So this will make things a lot easier, especially if you're trying to UV map this and not have to worry about separating it from the backside, just like extruding those faces that we did previously. And you also have control over the thickness, so we can change that as needed. So now what we can do is, if you wanted to, and I will turn off the sub-D modifier in edit mode again, I can actually turn these tries and make this corner even sharper if I wanted to. So I have that control. So I can press Control R for my loop cut tool. And you can see I can add in a vertex here. So I can do that on both sides. And what that gives me is, even though this is technically like a triangle shape, it still has 4 vertices and will create this as a quad. So that means you can move and edge slide these vertices now here on this corner to preserve that corner even more. So again, you don't need this, but it's just there if you want to have that control. So now what we can do is select all of our edges. So actually I would do this before doing that corner that I was just showing. Is select all of your edges and go to our panel. So if I hit N, go to mean bevel weight, edges, set that, we can now have control over our bevels, and then add that modifier. We can type in bevel, and then we'll add that under our solidify, but over our subdivision. And here you can actually, enter the amount. So I'll actually put in, change this to weight, of course. So we want to change that to weight. And then you can put 2 segments. You can use offset if you want to have a little bit control over the exact amount. So 0.05, or I think I need to go pretty low here, like 0.001. Or what's nice with these panels is you can use width type percent. So percent's nice because now you just kind of have a little bit more precision and control over this. So notice I can say, okay, I know that I want these to be all 20, 30, 40, 50%, and they're all there. Okay, so that's looking really nice. And we can see we have our corners here holding up really nice. So if I wanted, again, this really sharp corner, or if I'm fine with just having this kind of as a quad corner or even just split triangle. Okay, now of course you can grab this, and maybe I want to just actually keep that middle edge there, and we'll select those 2 edges on the outside and do a dissolve edges. Hopefully it doesn't crash, but it should be fine. It seems to be okay. I had that scene running for a long time. But yeah, there we go. Like now we have complete control over the solidify. We have complete control over, the thickness on how thick this is. We have control over the bevel and of course control over the subdivision. So a little bit better in the sense that we can change things procedurally versus doing it the other method. And again, I've used both methods and they work completely fine. So this is the workflow that I apply to any type of hard surface or vehicle type model when I'm ready to create those panels. So with that, I'll see you in the next one. Let's take a look at how to use Booleans with sub-D modeling. So I have a few different examples of some models here of how you can use Booleans to cut in and create intricate details to your model and then continue to take it forward and create a sub-D ready model. Now, there is one thing I want to emphasize here, and this is kind of what I was discussing at the beginning of the course, is that sometimes you can kind of work within this phase of just kind of working, Boolean, doing simple bevels, and creating these for early concept and design phase, right? Before you continue on and finish the sub-D modeling like I have here. So if you're creating something just like concept art, or you need to just create different iterations of the model, then 100% you are good to continue and just work within this work cycle here, this iterative work cycle of creating forms and doing the Booleans. But once it's ready to get in production, you're going to want a sub-D ready model, assuming that the pipeline requires it. So let's work here. Let's work on this model here with the cylinder. And you can see that I have a couple of objects here with the bool tool model, okay? So these are different cubes cutting out a cylinder, all right? Now, if I do Shift DX, you can see that there's nothing really crazy about this cylinder. It's a normal cylinder with 32 sides and one segment here on the bottom. It's also using a cap set of triangles here. And what we can do now is kind of manipulate and move. So like let me undo that and then create a cube just so we can recap how to use the actual Boolean add-on. So let me select both of these, hit Q, and then align objects, and I'll align it on the Y so it's perfectly aligned. Then like I did last time, you can move and position this however you want. So I can scale this in the Y, move, and once I'm ready to rotate this, so I'll do that in the Y. Once I'm ready to actually do the Boolean operation, so let me select both of these, hit / on the numpad. I will do Control minus on the numpad, and there you go. And so now we have this kind of live iteration where we can change and do a lot of this concepting that I was talking about. You can even change the geometry on the original model, the one that we're using to cut out. So you can see how I can add in edge loops to help kind of align some things, or I can even go in and let's say, well, I want to dissolve these edges. You absolutely can, right? You can experiment and kind of play around with this type of modeling to kind of help that early prototyping. Now, once you have this, let me just take this one since I already have it positioned, and Shift D, right click so it copies in place. And I want to apply all of the Booleans now. So once I'm done and I've gone through the different phases in the iterative design cycle, I'll apply all, move this back, press period on the numpad to zoom in, and then I can kind of focus in on making this sub-D ready. Now, of course, like I want to also select all of these edges here, and I will just outright remove these. So I'll just right click or press X and then dissolve edges. And then I can continue to work with setting this up to be sub-D ready. So let's start here with the cap. So I can select this cap here, and I know for sure actually these bottom edges, I want to run up and connect them at the top of here of this ramp. So I know I have 1, 2, 3, 5 vertices. So I can press Control R for my loop cut tool. And what's nice is I can actually just straight up add them here. So I'll add 5 vertices here. And then now I could select these vertices, press J, and that will now allow me to join these. So this is just that cleanup process to make this all quads, mostly quads, and sub-D ready. Then I can do Control R, bring this down, and then I can do the same thing, kind of join these with J, right? Now we're left with this n-gon here, so we're going to just use what we've been learning so far and kind of cleaning up this geometry by adding in edge loops and splitting this. I'm going to have an entire video devoted on how to clean up n-gons and tries, but this is a pretty straightforward example. So good news is, like, we've got pretty much all of this bottom area set up as quads, so we can kind of focus in now on this top. So with this top piece here selected, the first thing I want to do before anything else is do an inset. So I have this kind of boundary of face loops that I can use for whatever it is that I need. Okay. And I will actually let's split this geometry first, okay? Because the reason why, so we're kind of doing this as I go, is I grab these vertices, let's join these, okay? I know I want to split these here. And then with this, I'm gonna have 1, 2, 3, 4 of these edges kind of coming down because I know I'm going to need edge loops to kind of help preserve this ramp and detail here. So if I add in, let's see, let me hit escape here real quick, go to 2, and I want to cut here on this one. Will it let me? Doesn't look like it's letting me. Oh, I see what it's doing. It's kind of cutting across. So what it's doing is this. I can maybe go through the process and add in 4 edges here. So you see how it's kind of running up across this way instead of down this way. I don't necessarily want them to route up. So let's just select these and dissolve edges, okay? Because now what I can do is add the 4 kind of running across here. And then I can just kind of connect these like so, all right? So I'll cut these across, and this is actually, I'm doing this a little bit differently than what I did on the other one, but you can see now how things are going. Now I don't want to do this all over again here, so I can just do A, and then I can grab my symmetrize tool. So hit Q, symmetrize, and then symmetrize this from negative Y to positive Y, right? So really the main thing I'm just focusing on here is just cleaning up this geometry. Oh yeah, sorry, I did it the other way. So it should have been positive Y to negative Y. There we go. So far so good. So we're just kind of working our way up until we get to this part here. Now we can, how do we want to approach this? Now I can actually just kind of maybe, if I know I want 4 edges here, I can add 1, 2, actually let's delete this one because this is causing issues. Let's grab this edge and do a dissolve edges. There we go. So now I know I want 4, maybe I'll just do 3, okay? Because now let's localize that topology, okay? Because it's all coming down to this single point. So just using that workflow where we have 3. So now what I can do is just kind of use this edge here, and then we can just kind of continue to join these like so. It looks like I missed that one. So just merge that at last. And then here is I can now start to cut across. Okay, so let's do that inset here. So I want to do an inset as I'm going around. Press I for inset to help protect this geometry. So now things are looking okay. Actually, make sure we apply. If I leave here, make sure we apply, or I'll just outright delete that bool tool. And then we're looking pretty good. We do need to make sure that this geometry is kind of all coming down here at this bottom. Now, this could be a problematic area because what I want to do is cut and create a face loop that, let me escape that. I want to create a face loop inset essentially right about here. Okay. And you can see that, remember, we're kind of like extruding and cutting things out. Well, I have to make sure now I kind of cut across, and let's just create a supporting face loop for this detail. Otherwise, it's going to cause smoothing issues, okay? Something like this all the way around the model. And I don't want to use inset. Instead, we'll just now grab this and do a merge. And we can bring this, just kind of edge slide, so it holds that form a little bit. So let's take a look at what's happening with smooth preview applying to this object. And if I right click shade smooth, it's actually looking pretty good. Where now I can do again another symmetrize, and let's see how things are holding up. Good. That's actually pretty good, because what I can do now is disable this in edit mode, and I can, let's bring this edge here and let's just slide it all the way. So this is now becoming our edge that's holding this form, or this corner. And we're just going to edge slide these back a little bit. And then I will continue to cut this down as we go across, right? So as you can imagine, what we are about a little bit over 10 minutes in, and it's a pretty tedious process, but what's happening here is I'm just focusing on solving these puzzles of topology, okay? Because now if I grab this vertex here, I can just kind of start splitting these faces as we run across. And then we're just kind of connecting as we go, all right? And what I can do is just kind of continue to split these faces. And let's say I want to actually have, you can see that these three come here. Well, we can localize topology now. So if I grab X and then maybe I move this vertice, and then now let's just use this to add in some new geometry just in the area that we need it. So we're just now really using our knife tool quite a bit as we go along. And so now I can cut and split these just like that. And let's look at this in smooth preview, and things are looking pretty good, right? And we have nice topology in edge flow. So if I wanted to add one to hold this form up here at top, I absolutely can. And take a look at how that's looking. That's looking pretty good. And then we can just run another symmetrize, and there we go. And we have this edge. So now we have this edge kind of running here. So let's say I want to make this a little bit sharper. We absolutely can. So, you know, I bring this in a little bit closer, so it's holding that form a little bit. So it's a little bit more consistent. But the good thing is we have that topology and edge flow in order to do that. So let's kind of continue on with this piece. So I will do a J to kind of join that. And really, I just want to kind of cut this across. You can see I'm connecting it to like every two. And let's just continue on cutting this up. And we have these pieces. So it's all just, again, at this point, it's just a nice simple puzzle of, you know, where you want your geometry to be. So we have something like that. So it's just a matter of, okay, I know, you know, so now what do we have, right? We got some diamond quads, which is completely fine. We have some n-gons up here, all happening kind of on this flat surface. What I'll do actually is just kind of cut this. So this is, you know, what I'd recommend, just kind of playing around, solving. I want you to understand is that at the end of the day, if this is where we're at, I can hold and symmetrize this. And then even though we have a couple of n-gons and tries, if I smooth preview this, okay, it looks completely fine because we're on that flat surface and I took care of all of that geometry on the areas that matter. So here we end up with something like this, okay? And for the most part, it's holding up good. I mean, I don't see really much artifacts happening along the curvature. Let's say if I wanted to really make this a sharp corner, then I would start with a higher res cube. But this is completely fine as is. And then now, like, you get the idea where I can take this and then I ended up with something like this. That's really all it is. And I didn't want to spend a great deal amount of time just kind of clicking and solving that issue here. But I mean, that's the gist of this workflow. It's, again, a little bit tedious and it works completely fine. Like I can just kind of split this and do another symmetrize. So now we're left, is that all quads? I think I did I get it? Quads here, quads here, quads here, and then quads there. Yeah, so it works out fine, right? Again, it's just like a little puzzle piece, and then now we can add in geometry wherever we want. So again, I'm going to have a complete video devoted to that, so don't worry too much about trying to solve these issues, or just go look at the other video where I solve n-gons and tries, and then come back here, okay? But yeah, I mean, all in all, what I find interesting, right, is like I will go and align these objects here on the y and x, okay? And then if I move it now, both of these are using the same base topology. And what's great is that they actually have different types of topology. Why? In this instance, I run that kite running horizontal, and in this instance, I'm running it vertical. And I wanted to show you both methods to doing this, okay? So again, completely different way of doing that. And then I can, of course, finish this. I think that was one of the last ones, but I can have that triangle, kite, quad, but I'm actually going to leave that because you can see different solutions here, and you know, they cause different problems. But all in all, it all works out perfectly fine, and I'm pretty happy with the topology solving. But that's really the key thing. When you're doing Booleans with sub-D modeling, there is that process of cleaning up that geometry and using your topology solving problem skills to solve the puzzles of how am I going to take this very large n-gon and convert it into a bunch of tries. So try a couple different practice pieces, see where you end up. If it doesn't work, start over again, and just keep practicing on either flat surfaces and different unique surfaces. Don't go crazy and overcomplicate it, but if you take like a cylinder and a cube and just start doing that for a few rounds and do what's called topology studies with that, you'll be amazed how fast you're going to start creating this muscle memory of creating n-gons to and tries to quads. Okay, so with that, I'll see you in the next video, and I hope this one was a fun one, so let me know. In this video, we're going to be talking about non-planar faces and poles. And these are probably one of the main reasons why people get so many artifacts on their smooth sub-D models. Because even when you have all quads, you can still manage to get deformation and artifacts on your surfaces. So let's talk about non-planar faces. So for example, I have, in its simplest form, a quad here, a simple plane. And if I look at this in orthographic view, completely straight on, all four vertices are completely aligned and on the same plane. Regardless of whether or not this is rotated in a different axis, they're still completely planar. So they're flat. When it's not flat, when it's not planar or coplanar, this is what it tends to look like. And this tends to happen when you're doing manual vertex manipulation, or when you are going through using the knife tool and adding in new geometry. So it can cause a lot of surface artifacts. If you see this example here of this nice, simple curved plane, you may think, well, these are not planar. These are kind of curving as they are. But if I rotate this and orbit around, let's isolate so we're just looking at this, okay? And if I hit tab to go into edit mode and select these two vertices, each one of these sets of vertices are completely planar, which is giving us this nice ideal surface. So take this now, press Shift D, move it in the X, let's press period on the numpad, and now when you start to like grab a few of these vertices, so I'll just shift click a bunch of random vertices, then hit Alt S to kind of move on the normal and grab a couple more and move them downward, right? So now we don't have these, and it may seem simple, right? When you have issues like this, and when you don't have coplanar faces, it's going to cause a bunch of surface artifacts. And it's especially noticeable on more glossy and reflective surfaces. So you can see the highlight breaking up. So let's switch back to our other matte cap and look at this on actual issues here, okay? Shout out to one of my Discord members, Corey, who sent over this model as we were going through and I was developing this course, and he was part of my mentorship program. So I gave him kind of early access to some of the content I was making, and this, you better believe, came up. Okay, so what's happening here is if you look at this at first glance, it actually looks pretty fine. And I would say that Corey's model was like 98% of the way there. But what we ended up having on issues like this is you got these coplanar issues. See, it's this really subtle thing that drives us 3D modelers and 3D artists mad, because you're like, why isn't this surface looking the way that it should? Why am I getting this artifact? And if I turn on wireframe, you'll see everything is a great even distribution of edges, holding line, quads, all of this, and yet we're still getting artifacts. And if I look at this with, a different highlight material, you'll see it even more as you're going along with something a little bit more contrasty, like it's coming across there. One of the first things I do when people have this issue is I'll take a look at their model, I'll grab some faces, I'll zoom in, and I'll do this. I'll just start looking at it at these odd angles. And when I'm on Discords or Zooms, people are like, what are you doing? And I'm like, I'm looking for this. Look at this. You kind of get down and you try to get basically almost like parallel or looking down these faces, and this is going to show you where you have these non-planar faces and what's causing these issues. Okay, so we know what the issue is. Well, how do we solve it? Okay, so let's talk about how to fix this. And to fix this issue, we want to flatten these faces. And because what's going to happen is if you select some faces and right click with loop tools and just do a flatten, it's going to make other faces non-planar. So you want to select kind of the loop of faces, or really the faces that are connected to it as you're going. Because remember, if I go back to this here, you can see that these edges are all planar as they continue to go down the model. So using that, we're going to kind of select these faces as we're going. And sometimes I'll actually need to kind of go in and just move and manipulate these faces here. So if I start to move that in, so I'll start to kind of make these vertices nice and straight. So where I'll kind of move this where that's completely nice and flat, or flatter, I should say. And then that will allow me to now select these sets of faces holding Control click. And let's look at it this way, right clicking and doing a flatten, and there you go. So we'll continue that as we select these faces, right clicking and doing a flatten as we move along this model. Now, you may have to do kind of a couple of iterations of this where you're kind of going and flattening to really kind of get rid of these issues. Because now if I look at this kind of from the side here, you can see where we're running into issues. Now, I have an example model here that actually, this is the one I created. And if I look at the faces, look at the difference, right? In my model, I keep the faces completely planar. So when you're looking at it here, you don't see any faces or vertices protruding out, right? For example, like if I accidentally move that, those faces are no longer planar here. So again, applying that concept here, we want to make sure that that looks good. And I would say we even want to, like, we're looking at this set of vertices. Now, all of this here, you can actually kind of scale these in the X and, excuse me, not the X, the Z and the Y. So you can see where that's kind of causing an issue. So you can kind of get all of that aligned. So I'll just start kind of here and completely remove these vertices, okay? So you can do SZ0, see how it kind of flattens that out, and then SY0, and that kind of also flattens that out. So now we're just kind of making things more planar. Now I'm not going to do it for the whole model, but this should give you a good idea. So now if we're kind of jumping in and out of smooth preview, that's going to help our surface a lot better and make our subdivision behave more predictably, right? And that's what we've been talking about in the course a lot, is the predictability of using sub-D modeling. So if I look at that, and you can see where faces no longer are planar, I can right click, and if I do a flatten, that'll make these completely flat, okay? So now we start to look at it and we're starting to orbit around. At least I fixed the left side of this. I'm not gonna go through and fix everything, but doing that to this surface is going to help fix these issues. So now I'm looking around orbiting, it's starting to smooth things out. Everything's looking really good compared to the left side here, and then compared to the other side. It's one of those subtle things that, I didn't necessarily learn until like I just kind of learned it like on the job, and nobody really told me about this. So that's why I was like, well, let me make an entire video devoted to this when we're talking about non-planar faces. And then now let's talk about poles. So poles are another one that can cause distortion and surface artifacts in your models, okay? So if I zoom in, let's look at this series here. So this is just kind of a section from the scope that I modeled here. And if I zoom in, there's really no way around this, right? Because I know based off the reference that we kind of have this bridge piece and we have this extrusion kind of coming up, and there's really nowhere way around it. However, I'm not necessarily protecting this extrusion because of the way that this works, right? Because you may think, well, if I go in here and just kind of cut across, that is in with the way that this is set up, introduces its own series of problems, right? Because if I start to merge that, you're like, oh, well, crap. Like now we run into this issue where it's breaking that form, right? And that's where this pole here and it's causing kind of, again, I mean, it's causing non-planar faces, all right? So there's a couple of ways to address this, right? Because what's happening here is if I go in and do a bevel, right? And if I do a bevel on all of these together, you get something like this. And it kind of holds up okay, and is honestly, you can get by with pretty much this as it's going. But what made this challenging, that's why I just love modeling different pieces, is that you have this harder edge running around here and then a softer curve profile here. So in my case, I couldn't just uniformly bevel this, all right? So would anybody notice it besides me? No. But we still have to find solutions and model this as closely as we possibly can. So you can see here with this bevel here, it introduces another set of issues, okay? So my solution to this is you want to minimize your pole and essentially the spread and the impact it has on the rest of the model. And I can't use bevels because if I happened to bevel this, it will change the curvature profile. So if I had something uniform, a bevel could probably work, but I'm just trying to give you context as to, well, now if I take this, Shift D, move it in the X, and let's kind of isolate and just really zoom in on this. Now, what I can do is just Control R, grab my loop cut tool, and just bring in an edge to kind of help reduce the impact. So this is coming back to those concepts that I'm talking about with edge distribution, with mesh density, right? So I'm just making sure that as I increase the amount of edges, I'm really just making sure that I consolidate the area of impact to just a small set of faces, right? Now, if we look at this, we can see that it subdivides much more predictively. And then if I wanted to, I have this geometry now where I can adjust the curvature and the profile of this. Now I have to be careful about moving it up in the Z because now we're getting that non-planar face. So this little corner was causing, I wouldn't say it was causing me a lot of grief, but it was just one of those things that I didn't expect to give me, this much work. So I could also move this up, this edge up here and kind of GG slide that. And you can see now I have two different curvature profiles kind of running around where this is a little bit more curved and this is a bit more sharp kind of running around. So just one way to address these. And this is more just kind of talking about very specific instances. So I want you to understand that this is not like a catch-all. This is very specific to this model, but it is definitely something that warranted me kind of talking about it. So here's another example on this kind of anchor screw piece, right? And we're getting this issue. Why? Because of this bevel right here, okay? So looking at this bevel, it's causing this issue. Not only that, I mean, it is causing this really bad n-gon to appear here. So this is where I would bevel the overall, essentially, silhouette, the edge that runs the silhouette of the model, and then I would manually go in and add in the edge here. So you can see I removed, what exactly am I talking about? This edge right here. This is the problem one if I let Blender bevel this edge here. Actually, let me control click this up to here. And we let that go, and then now we're left with this n-gon here, okay? So this is actually a little bit better because I made sure to go through and kind of clean up some of this geometry. However, it still runs. This is kind of what I ended up with initially, okay? So we have to make sure that we give supporting loops too, because the other thing is, it's all about containing that geometry. You'll notice here, I have these two edges supporting this geometry. If I look at this model, let me turn off viewport visibility. I don't have any of that here. Okay, and that's what's causing a lot of that issue here as well, is because remember, I talked about containing the geometry, containing those poles, containing that deformation. Okay, if you are able to contain this edge here, this edge, and give it the support that it needs, then it will subdivide predictably. Then I make sure that, because this was another interesting one, it kind of comes back to the coplanar thing, where now I have these three or these faces here that are kind of transitioning from curvature to flat, but you make sure that you have flatten, and it will go through and flatten that geometry. But all in all, this behaves as intended, subdivides as intended. I don't see any noticeable artifacts, noticeable distortion. Everything's holding up really well. So that's just an example of, you know, a bunch of different instances where I dealt with coplanar faces, non-planar faces, poles, and how to manage poles for your sub-D models. So hopefully you found this helpful. Areas of kind of do's and don'ts. Let me know if you want me to dive into this in further detail. Hopefully this gets you set up, because now we are about to jump into our next modeling exercise. So I'll see you there. Concave quads and corners. Why are they a problem? If you get anything from this video, you absolutely want to avoid them. There's really never a reason why you need to use them. So let's talk about it. With concave quads, what you have here are two types of quads, right? A four-sided polygon. One is convex, which means that it's completely, all of them are outside here. And then this concave version has this vertice kind of coming inward, okay? And so you're left with this type of shape. Now you might say, well, when and where would I actually use those? I see this a lot on corners, okay? Especially for people earlier on, they're like, oh, well, let me just throw a couple of triangles here. Let me hold this corner and move on with my life. But you will get all sorts of issues, all sorts of pinching, all sorts of artifacts in this area, okay? It comes back to that predictability. It's going to cause pinching artifacts because the sub-D modifier does not like dealing with something like this. So you want to make sure, in addition to keeping things planar and managing poles, you want to make sure that you know how to handle these. So we have an example here of this shape that has all sorts of corners. So this is a perfect model to practice with. Let me alt-click. Let me actually get to our select box. Alt-click, alt-click. Let's completely we want to remove these edges, right here on this extrusion, because we want to preserve this corner so it's a nice sharper corner. Well, how do we do that? It comes down to adding in some extra support loops here on the outside. So what you end up with is these three faces, okay? So we have these now once we've added those holding lines, and then now we can go through and use our knife tool. So I typically do it in this order of operations, where I will start with splitting this down the middle. So you start with your center face and split that down, and then you grab the next edge, that supporting loop, and that will meet at the neighboring corner like so. Okay, so then you can start removing and cleaning up your edges. So it's these two edges here that we want to remove, in addition to now these edges here, because these edges here are running all throughout the mesh and we don't want them. So, or I should say, we don't need them. So if I press X, dissolve edges, boom. Now we have this edge here that's kind of helping supporting our geometry without routing it anywhere else. And so this works perfectly fine for what we needed. And then I can use this edge now to kind of help and move. And so this is giving me this nice sharper corner here compared to using this geometry. And then it also gives us a nice face loop, right? So as I select it, you can see it completely stops wherever there's triangles. So it cleans up your model a lot nicely. And let me add in this edge. And so let's do this one more time on this bottom edge. So again, the two edges that you need, these two here, right? And we want to kind of terminate them specifically in this area. So instead of, again, routing and having all these edges run the length of the model, what we can do is essentially create, it's like adding in an end set. So we'll split that middle polygon down that way. And then on this face here, we will continue to bring that edge all the way down like so. Once those have now been added, we select the inside edges like so, and you can dissolve those edges. And now we can remove, the problem is on the other side, it's not symmetrical, but I can do it like this, and then I can just deselect the other side. X, dissolve edges. And there you go. So now you're left with this nice area. So that is the way to add in extra geometry on your corners to help support it, so you can avoid things like this. So take this model, kind of practice on how to add things in there. I mean, sometimes you can leave it as an n-gon, you can leave it as a quad or tri, but it's going to, no matter what, cause surface imperfections and artifacts. So here you can kind of see a solution to that. I have kind of a good side and a bad side with things being beveled. So if I symmetrize that from positive y to negative y, this I would say is the nice version, right? Just completely nice quadded up, except I have a bevel here that's causing n-gons, but it actually subdivides okay. So if I wanted to kind of really tighten this corner up, you can kind of see how things are. I have these control loops. The other reason why this is being stretched is if we go back to the previous videos and lessons, our holding lines, this holding line that's supposed to preserve the corner, is being pulled away. So when you know that, you should already know the solution. I should go in and add in an even distribution of edges, and that holds our corner way, way better, including adding in edges here. So I don't want to add in that face loop because I didn't add it on the other side, but it's there for practice. So use it, and hopefully that helps you understand. Avoid concave corners and use this technique for corners. By the way, that can be used on any place that you have these corners. So with that, I'll see you in the next lesson. N-gons and tries. So you've gone through the entire process, you're modeling, you're using the knife tool to cut, insetting, extruding, and now you're left with a bunch of triangles and n-gons. So we're going to discuss techniques on how to convert them to quads. So let's start here at the top. you can see I got a series of triangles, a series of n-gons, and let's figure out how to fix them. So as you can imagine, when I have a triangle kind of coming over and I added an edge loop and it's terminating at a single point, one way that we can fix it is by one, just merging it down. In its simplest form, it's like, do you need it? Yes, then we can talk about it. Otherwise, if you have a triangle, you can outright completely dissolve it and remove it. Now, most of the time, if it's there, it's for a reason, right? So now we can talk about, well, if I add in this triangle, or excuse me, edge here to help remove that triangle, what happens now by adding in this new geometry, I've created a new face loop, right? So that means I have this face loop, right? And once you see that, maybe you didn't see that even before I highlighted these faces, but by adding this new geometry in, it converts that tri to a quad and creates this new face loop for us, right? So again, if I shift D, let's move this over the Y here on 6. And if we want to do that, and you can do that in any direction, I could also just outright add one right here, and we can create a diamond-shaped quad, right? And then we still have that face loop, right? Where is this face loop now? So if I click that, it's still right there. So it just depends on the direction that you want to route that edge. So this one's kind of a simple example, but again, the same thing applies. If I shift the Y and let's move this 6, we have this where we want to convert this triangle. Or this is actually a really good technique of splitting up a quad to generate and create new edges. So again, if I go in here and I start to add in that geometry and start to move it, we're creating face loops that run in any direction, right? These face loops and edge loops, which is helping you now learn how to route and flow geometry, right? So again, I select these, boom, we have a face loop running that way, boom, we have a face loop running that way. These are techniques, by the way, that can be completely combined with the previous video of localizing topology. I would say we take that video, this video, and there'll probably be another video just on edge flow and understanding that part of the topology process, okay? So now, right, this is how I would fix tris, okay? Going through either outright removing them, adding a new edge loop, and creating new face loops from that. Now dealing with n-gons, okay? So n-gons, so we have tris, which are three-sided triangles, right? Polygons. Then we have n-gons, which is any more than 4. Now we need to understand this because this is super important. You sometimes will have this where you have 6-sided edges or 6 segments, okay, which is an even number, and then you have sometimes a 5-sided one. Now, no matter what, if you have an even amount of edges here for an n-gon, then the easiest way to fix this is just by splitting and adding in new geometry. What do I mean by that? If I grab my knife tool, I can just split, and these are way easier. So even n-gons are way easier and super easy to fix, okay? Because you can essentially take this edge now and use it to kind of route all your geometry. So that also gives us a new face loop, right? What did we generate from that? So if I undo that, we can see by closing that, so I'll actually use J this time, we have now this new face loop where we can actually use this to kind of route geometry. You can also use it to combine them or add them in any direction. So let's say you're like, well, I actually want to terminate it here. So you terminate it, but now we're left with a tri and these quads. Well, we know how to deal with triangles. We can simply add in this new edge loop just like so, and that allows us to move and create these new face loops here to kind of help route and move our geometry. So again, just kind of going back, very easy technique for even-sided n-gons. Now, this becomes a little bit more challenging when you have odd n-gons, right? So this is going to be 5 or more. So 5, 7, 9, so on and so forth. So if I take this one here and I move it in the X here, and Now it's like, okay, well, let's use the same technique. Let's just split it. Well, it's not going to work nearly as well because now no matter what you do, and don't pull your hair out, it is mathematically impossible to split this to have two even quads. What you can do is just split that geometry. So now we have at least one quad, right? So we have this quad here, and then you just add new geometry. So we're just breaking it down into simpler pieces. So that's what I mean by it's a puzzle. You're taking these shapes and trying to convert them to tris, which could then be more easily converted into quads. And I would just take this geometry and just continue to kind of play around and see what you get, right? Like, of course, I could take this n-gon here and I have to add new geometry to convert it to a quad, right? So just simply splitting that down will be completely fine. So if I undo that, now if I, again, cut this, if you try to split it, there's no way to convert this to be quads without adding new geometry. That's the main thing to understand. You could keep this geometry here with even, and without adding new geometry, boom, I can do that like so. But here you can't do that. You have to always add. So if you have an odd-sided n-gon and you can't remove edges, that's how you would do that. So I would just continue to do that. And I mean, see what happens if you go through and let's say maybe I split this in half like that, or even add in this edge loop here. Now we're left with this new geometry. Another thing you can do is, now that I've added that, you could actually delete and collapse, right? So that's another thing. And I brought it up at the beginning, is I can merge these at center, and that allows me to combine this geometry. So don't forget that you can also merge, collapse, delete edges as far. And one of the most common ones that you're going to deal with is this instance right here. So let's just Shift D, move this over in the Y, and take a look at what's happening. Is you go through, like, how do you get here first, right? It's always going to be one of those instances where you're manually cutting in edges like this. You're like, okay, I know I want to organically cut in across, and so you get this, okay? Now, one way, like I said, is you could merge this down to the center. And so now you have 1, 2, 3, 4, all of these are quads now. Another way is you can split this. And so the main thing I want you to understand is whenever you have a tri plus a 5-sided face, these are probably one of the most common ones. So then you can just simply split this tri in half, which will give you now 2 quads, or I should say 3 quads, because now look at this. Boom. We have 1, 2, 3 quads instead of a tri and an n-gon. So super, super helpful. And then, like I said, remember, if you have these tris in here, we already know how to deal with those by routing in and adding in that geometry, or by completely merging it down is another technique, right? So that works completely fine. And then we have this where, you know, sometimes you're left with a tri and an n-gon from cutting, and you can either split it in half or merge them, is another way to handle that type of geometry. With all of that, right, all of these workflows, by adding in edges, removing edges, merging, and understanding now that you have tris, even n-gons, odd n-gons, and how to convert them down and break them down into smaller pieces, you now have all the tools necessary to solve any topology example. So just like maybe if you like Sudoku or playing games, just treat it as a puzzle and breaking it down into smaller topology pieces. So with that, I'll see you in the next video. Let's talk about how to use our guide mesh for sub-D modeling. First of all, what is it? Guide mesh is the process of having a base mesh that you are taking your detailed mesh and projecting and shrink wrapping it to, right? So let's go through the whole process. You'll see that I have the entire workflow right here, but we're going to start from scratch. So bringing the sphere in, which really is just a cube. So I just created a cube, applied a sub-D modifier to 3, and then if you hit Shift D, X and you grab this one specifically, let's work with this. Now, I want to apply this, so hit Control A on the modifier list. So now we have some geometry to work with. The key thing to understand here is that if I look at this from the top view, it kind of looks spherical, but it's not. So if I go into edit mode, grab all the vertices, you can actually go to Mesh, Transform, and then it should be under to Sphere. I have it right now set to my quick favorites, or it has the hotkey Shift Alt S, but I never use the hotkey enough to remember it. So anyways, you hit your quick favorites, or you go to Sphere, and actually let me look at it from the top so you see it more obviously. So Q, to Sphere, drag it, boom, look how it now becomes a sphere. So undo, redo, now it's a perfect sphere. Great. With this now, this model is our guide mesh. So I want to duplicate it, Shift D, right click, boom. And for now, let's just jump in here. I will change this and I'll call it guide mesh so we don't lose track of it. Hide it, and now we'll continue to do our work here. So with this now, this is our base mesh, okay? So the key thing to understand is you need to make sure that the guide mesh and base mesh are essentially the same, in the sense that everything is the same except the paneling hasn't happened. So now I will go through and do the paneling, and I'll also select these edges here. So we have something a little bit asymmetrical and a little bit more organic. So Control B bevel, and boom. So we can bevel that one, and I do 0.01, or you can keep it a little bit tighter, whatever, it doesn't matter. And then you hit X to delete it and delete those faces. Okay, so now we have everything broken up in panels. And all I'm doing at this point is applying our panel workflow. So with all the faces in separate panels selected, you just press I to do the inset, and boom. We'll do this a little bit tighter, maybe 0.015 will work for what we're doing. So we want to preserve our corners. So I won't do it on all of them, but I will just quickly go through and preserve these corners here, right? So something like this, and hit enter. And then let's just quickly add it to these 4 corners here, and we'll move on to the next piece. We'll move on to the next part. So all I'm doing is just preserving the corner, hit enter, and I forgot about these last 2. And this should be everything that we need. Great. So we have that. Now, if I do a Control 2, and you can see I applied a sub-D modifier, this looks fine as is. However, if I wanted to, let's say, hold this corner, hold this form, and add in this geometry, we can add in and localize it to this area, specifically here. Because the last thing we don't want to do is, remember, we're using our technique of localizing topology. I don't want to start adding in extra edges here when I already have the form done. But what we notice now is we get the dreaded pinching and surface deformation. You can also see it here, right? Like if I want to hold this corner as well, I can Control R, insert edge loop, and you just get all sorts of pinching here. Okay, this is problematic. So this is where our guide mesh comes in. If I grab my guide mesh now, I want to apply a sub-D modifier to it. So what's important is we have my base mesh, so I don't want to lose track. So I'll call this base mesh. This base mesh is being subdivided at 2 subdivisions. My guide mesh, whatever it is going to be double whatever the base mesh is. So with our guide mesh selected, press Control 2 just to add a sub-D modifier and change the levels to 4. So it's going to be double. So it's going to be super smooth. Now we select our base mesh and we can apply a new modifier called shrink wrap. And I add a shrink wrap. Then I can select, so let's see what happens exactly to this topology. Here is I can eyedrop my guide mesh, and look at this, boom. And now it's projecting on it. So once I go out of smooth or wireframe mode, look at that. Look how smooth this looks. And just to be doubly sure, I can go to a much more obvious matte cap here, and I can grab maybe this reflection here and toggle on and off our shrink wrap modifier. And look at that, surface artifact completely gone. Honestly, when I first started doing this, it almost felt like cheating, right? So the reason why is like it does need a little bit more preparation, and it feels like cheating because you can actually have pretty bad topology here with this shrink wrap modifier doing the heavy lifting. Okay, so you have to be careful of this. When and where you would use this, this is 100% used in something like vehicle modeling. We use this heavily to do concept designs and whatnot early on in the process without having to use NURBS and spline modeling. So any talented or skilled modeler could use this as a way to create deformation and artifact free surfaces. Great. So now that we know how to do this, I can go back to my matte cap here and finish off the rest of the detail. So we can add in a solidify modifier. And where do we want to solidify? We do need it after the shrink wrap and after the subdiv, okay? So that is one thing you have to keep in mind, is that it will make a much more heavy model. But again, it's worth it because it gives you the detail that you would otherwise have to have a lot of hard time dealing with. So again, let's just keep going. You can again do this only rim, no rim, and 0.01 is fine. And then if I want, we can grab the, so I'll actually turn solidify off in edit mode. And we want to set all of these to have a bevel weight. So selecting all of these edges, boom, everything looks good. And let's apply a mean bevel weight of 1 and head over here and add in a bevel modifier. So again, just applying this paneling workflow, and really the order of the bevel and solidify doesn't really matter. Or it kind of, oh no, it does, because we do want it to be after the solidify. So here I can set this to %, and I can set this to weight, and we can start to slide that and increase the segments to 2. And then now you get super nice hard surface, hard looking panels. And here's what's great is that I can continue to work like this and add in more detail with this being fully non-destructive. So I go through and select circle, maybe I adjust the angle a little bit, and I do an inset, and from here I can go through and let's say I will do another inset, okay, grab this and bevel this geometry. So I'm creating kind of a new panel as I'm going along, and I delete my faces, and then boom, you've added brand new geometry. And you just need to make sure that you add anything new from these panels to your bevel weight modifier, and there you go. So hopefully you found this useful, and understand that when you're using this type of modeling, it does take a little bit of extra preparation, but it is something that is fantastic to use and fall back on whenever you're doing any type of hard surface modeling. So I can't wait to keep sharing more tricks and tips like these. So hopefully you found this useful. And if you have questions, let me know in the comments and in the Discord. So I'll see you there.